Namaskar, good morning, good day, Assalamu alaikum, Sat Sri Akal, Vanakkam. This is Engineer Suraj Singh speaking from Bharat, India on September 11th, 2020, another day of life and super critical day. In a sense, our pandemic is concerned, COVID-19 is concerned, and address to you regarding engineering management and management engineering and organizations and related subjects of engineering, civil engineering, coordination engineering, safety, health, designs, constructions, etc., etc. Various issues regarding profession. Profession, which is like a religion, and I am interested to talk about that. Not religion of faith, but religion of service to God and service to people of God, because it is service to God, it's people of God that are being served. So it is very important. And here is Chartered Engineer India, Chartered Engineer designation according to Royal Charter of Institution of Engineers. This Royal Charter allows this designation to every corporate member of Institution of Engineers India, and Institution of Engineers India is that institution which is celebrating its 100th years of establishment, 100th year of establishment, because it was established in 1920 and this is 2020. As an institution, it's now 100 years old, and as a chartered body, it's 85 years old. Charter was granted in 1935, and that's why it's now 85 years old charter, and it's moving in that direction successfully, that it achieved certain objects, it did not achieve certain objects. Our institution has to see what is that achieved and what this has not achieved. And being corporate member, I am integrated part of institution. I mean to say, I am original member of institution. I have been member since 1981. I was associate member. Then in 1986, I was elected as member. In 2016, I am sure I was a fellow of the institution, and that's what institution is about. It's an institution for public, it's an institution for nation, and it's an institution for world. That's engineering, and engineering means worldwide profession. It's not simply saying my country profession or your country profession. And engineering means we have to live with engineering. We cannot live without engineering. Engineering is a part of life. It doesn't matter where you stay. More than you can say, our life is connected with engineering every day, in every time, every day, everywhere. We are directly connected to engineering, if not engineering profession, but in products of engineering. We use everyday products of engineering. Product of engineering we use every day, and this is COVID. And after that we say, is God's creation or virus? We have to decide. This is engineering, management, organization, systems, change, quality, all that, and challenges, human thinking, and then you can say general specifications, and all that which is in this. And this is soil, etc., etc., etc. So we have to think all about that, and this is which we do every day. I'll add something to this. I've not done that, but this is guide what we are going to talk in this, and this is where we think of. This is all about that, and then coming back to talk again and again and again. So my dear friends, engineering and profession of engineering and religion of engineering. I would say religion of engineering. Religion in a way that as an engineer, as in every profession, as an engineer, as in every profession, you have to work. You have to work majority of hours of day. When you work in engineering, whether you work in office or you work on sites or in factory or in industries or wherever you work, you have to spend about 75% of your time at work. Once you are an engineer, you are not controlled by 8 hours or 10 hours schedule. That is only for papers. But because engineering is such a world where there is no limit, if you are really professional, there is no limit. Even you may not be in chair that time, but you are at home, and that's also some chair because you think, you keep thinking, and that thinking itself, that thinking itself keeps you occupied. Even your family, your wife, your kids, but your mind is of course simultaneously away from that due to certain problems or due to certain other issues related to your profession. COVID is working, we know every day it is nothing new, and it is breaking minds of people, scientists, engineers, other people. It's breaking their minds in a way that whole world has changed. World has changed from, world has come to webinars status, and it has come to a status where you have to keep off everybody, and is shaking hand is also now a kind of alien activity, and you can say even you are not able to kiss. That fashion, that so-called advancement is gone. Means life has changed just in a couple of months, which you never expected. You did not even agree to think of that for years. Really, it is extraordinary achievement by COVID, and we should appreciate COVID. That without telling someone, automatism has come to public, and now this. It's also unfortunate that the infections have been advancing, risen. America more than 63 lakhs or 6.3 million infections, and around 200,000 deaths. Around, I'm not saying exactly, maybe 195,000 or whatever. And we, Bharat, India, are now with the pride, we can say, we always say Bharat shall stand number one, India is always at number one. So we are going to see that dream true. We said to come true, and that dream is going to come true. Already it has come true in number of cases every day. Yesterday it was 95,000, more than 95,000. So on an average you can say 80,000 per day, let us say. So we are going to say 24 lakhs, or you can say 2.5 million a month. So we are now 45 today, maybe more than 45, let's say 45 lakhs or 4.5 million, and they are now 6.5 million. So we are not far away. We are in competition with America, I should say, in this chasing sense. So it's not competition yet, because we are always pleased to be number one. So this corona has listened to us, and this, my friend COVID, is bringing me to that level that you are the Bharat Vasi. You are number one. So congratulations to Bharat people. I should say, what should I say? To society, that sleeping one. I openly say, as a Bharatwasi, that we are a sleeping society, we are a non-serious society. This we have proved with COVID also. We are still not serious. It's unfortunate. I don't blame government, because I don't consider government as a functional one. Government is not at all efficient. I don't give any credit or debit to government, because I don't consider government is working at all. You may think whatever you want to think. I consider people of this country as government, because this government we are talking of is different. They do not know what to do, but public should know what to do. After all, this nation belongs to public. Every citizen of nation, this nation Bharat, is honor of this nation. Like every other citizen in all other countries have same rights as we have. But I think we do not value our lives. We do not value. I am not talking on behalf of those who are riches, who are in IACLEON. They can manage themselves. They have plenty of money. They can go to whichever hospital they want. For them, there is no barricade. They can spend millions of rupees on their treatments, and they have done. We have seen many top people cases who are very high celebrities or politicians. For them, there is no problem. Problem lies with that 80% population. I think 60% of which is very poor, and unemployment as well. Now, our youth are unemployed. Many percentages of our middle or lower middle or upper middle classes are unemployed. If they are not unemployed, they will soon be laid off. That's also true. So that is a question of alert, and people now taking excuse that, oh, this is everywhere, this happening all over world. What do you mean by happening all over world? You have your own country, your own methods, your own decisions. Care for yourself, others won't make. In my people, if I am careless, say I cannot take my own care, who shall take my care? I know that there are no major facilities in our hospitals all over this country. We don't have adequate number of doctors or nurses. When we know this is there, then why don't you take precautionary measures or preventive measures? Yes, you are poor, you are not very intelligent, you are not educated well, but this doesn't need education. The prevention is better than cure. So you take protective measure. This is nothing big. Because I'm not telling just because I want to tell. As a part of social survey or social observation, I keep a watch to whom I see, and I know that more than 70% people are not serious, really. And those who are serious, they too are not serious, because there is some, mask is hanging here, it's closed there, nose is not closed. Even educated people do that. And I think there's a competition in that how not to use mask. Really, and sometimes I feel pity on those people who do like this, particularly those who are educated early on. They have one university degree, or they are in such working position that they are supposed to assist others. But if they themselves avoid it, they don't take themselves, then I don't think then you are right citizen, you are good citizen. Yes, you first of all, you don't have any right to spoil your life. Secondly, you don't have right to spoil other. So, because many people come to my house, because we have a temple in our house, and those people come to that temple, and I see that same. And when I walk on road, I see same. And I see people are on road, I see this same. There is no difference. You may be a hawker or a vendor or an office goer, or you may be somebody else. You are of that nature. You take it easy going, and if you talk to them, this is, though there's no problem. Means when there is no problem, it's every problem everywhere. When one person says there is no problem, I do not worry about COVID. This means you are challenging worlds, you are challenging others' lives. If you say I don't care for this, I am not afraid. This is not question of you being scared or afraid. Question is what happens to you and what happens to others because of you. That's the point of view. Say you, okay, I excuse you, I forgive you that you are not responsible for yourself. But are you responsible for others? Because of you, someone else is infected. You should understand theory behind this. You should understand mechanism is working. You are sitting somewhere, some in public place. Somebody else has to take your place later on. And if you drop somewhere, if your drop is left there by chance, by cough or by nose or by something, or even by exhale of your respiration, and you go, and after that somebody comes in that place and sits, and that will inhales. So you have indirectly, without knowing that you did that, you caused infection. And that's my point of view, that you should use intelligence. Little intelligence is enough for this. You don't need a graduate or doctorate degree for this one. So COVID is now more than 45 lakhs in this country according to yesterday's report or today's report maybe, and 90,000, 95,000 cases. This means curve is going up. What peak level it gets according to my calculation, again I say, it is around 8% of population. And if you suppose you conduct tests to all people of this country, you will find that 8 crore people or 80 million people are affected on this day of September 11, 2020. And this is calculation, because every day I keep a watch on that. and find 8.24 to 8.5% infections. Before it was 10%, now on an average you can say it's 8.5% or 8.25%. This is not a small figure in a country like Bharat, India, which is having population of 1300 million people. So just keep population factor discount for 30 crores and keep just 100 crores or 1000 million. In this 100 crores, if 8% people are infected, what's your rate today? This means 8 crore already there, 80 million already there. And if you do not control it now, then in future it shall become 16 crore. So what shall you do? Because your your testing capacity is around 10 lakhs or 1 million a day. If 1 million a day means you can say 3 crores a month. 3 crores a month means do you need to have 3 crores a month and 130 crore? How long can you do this? That's long. We are very weak in testing. In a country of 130 crore people, this is very small unit day testing. So we have to do something for this. Otherwise, we are we are, you can say, major center of COVID now, not other country. This title we have achieved now, which we did not expect even. There was a day when there were only 500 cases and lockdown was declared. Economy is everything I know in life, but it's not everything as far as health is concerned, health sector is concerned. If health is gone, you can't live and you can't live healthy. So you can't work also. If you can't work, you can't make money. We have to think that way. Previously we used to say if character is lost, everything is lost. If health is lost, something is lost. And if money is lost, nothing is lost. This was general saying, it's also valid today. If your health is lost, means you can't function, finish. Maybe you lose your life first of all. Or secondly, if suppose you do not lose your life, you lose your health, you lose your immunity. And you then means you have a guest in your body, uninvited guest, corona. You may come out of hospital or you may come out of your isolation. That doesn't mean that you are recovered. It doesn't mean that you have recovered. Again and again I stress on this point. They say, every country is saying we have recovered. This is all fiction, This is all hoax. You cannot recover from COVID-19. This is a state today. Maybe tomorrow something else. Today, according to status, this day on September 11, 2020, you cannot say somebody has recovered. On what basis you are saying? What's your basis? Only basis is that you have been discharged, and that is discharge, that doesn't mean recovery. This means that particular immunity is with you, but that infection is in with you. That infection is now stopped to work on you, but its root is there. That power that was inside you is still inside you. It has not come out. It has not been diminished. Yes, it's not very active, but when it gets its environment suitable for that action, it shall react. This we have to understand. That point is very important to understand by all those who have been discharged, that don't think you have recovered. This is fake statement. This is misalignment statement. Until we have treatment, there is no treatment today, and there is expected that in coming 1 year or 2 years, there may not be any treatment. Treatment comes out only when we understand what is root cause, and that root cause we don't understand. Still they talk symptoms. They started SARS. Now SARS only for name's sake. It doesn't work properly, because it's not only respiratory system this attacks. This can spoil your cordial system. This can spoil your neuron system. This can spoil your blood circulation system. So there are so many ways it can spoil you. I'm not a doctor, neither am I a scientist, but common sense, with common sense I'm saying, being a safety person, health person, environment person, because that's a part of my job as well. If I'm a civil engineer, of course I must know safety, health and environment and ergonomics, and I must know quality and all that. That's part of this profession. So based on that, it is in the community sense, on the sense of industrial workers' protection, I'm just stating that whatever I could gather information from this COVID is that there is no way out of this till now. There's no exit sign with this. It's still in everywhere, and it's everywhere. The case increase itself is telling that there is no one to look after, and that's a fact. Government has failed, people have failed, medical science has failed, the scientists have failed. As everybody, there's a uniform failure in all sectors. So it's not question of blaming, question of means God doesn't want to tell you something. God wants to undertake, secrecy, underline secrecy, and because God's work is always secret. If this human work or some environment from the work, it will come out and tell you I'm this, but God never tells you what it is. It never tells. This is the standard of God. Everything God wants to keep secret because God is top professionals in all professions. So that's what I wanted to say about this because again you find the West, complete West is in its attack. Complete West, and not only in its attack, there are maybe fires somewhere, and there may be some cyclone somewhere, and the temperatures are rising day by day, and something falling day by day, depends on weather. So it's such multiplications, for example, high humidity. Now I'm sitting in an area where humidity is 85%, temperature is 27 degrees Celsius. Both conditions are pro COVID-19. I can't help it. Though I'm sitting on second floor, that's why I'm not using mask because I'm alone here. There's no one. But when I go outside, I use this, and I support use your handkerchief better rather than using mask because mask always comes down. But once you tie up handkerchief, it protects your nose as well as your lips and your mouth, and also because it covers your cheeks also. So and your up to your eyelids, or you can say not eyelids, bottom portion of your eyes it covers. So it's better otherwise also. Even if you are not infected, you protect yourself from infection. There's no top line also from where this COVID particle can enter. But in mask, because mask is always very very light, and it comes down, and there's a gap here, there's a gap here through that annular space between the surface of mask and surface of your cheek. This annular space is enough for this particle to enter in either through your nose or through your mouth. So that's what I'm saying. If you use a handkerchief, it's much better than mask. It's up to you. I'm just suggesting. If you use Google it's better. Google or use glasses, it's better because it can enter through your eyes as well. So whatever way you adopt, be gentle citizen, be intelligent citizen. At least in COVID, you must be intelligent. It's spreading very fast. I am finding it's spreading in such areas where it's not expected to enter in, but it is doing its job because it's very rapid movement. It has very rapid movement, and it doesn't give us something. It's the efficient worker of God. It's efficient team of God. So I respect that way as far as the efficiency is concerned. But because this efficiency goes against humanity, that way I raise concern about that. So I should say that do not think money is everything, economy is everything. Economy is useful only if you live in this world healthily. Otherwise, there is no use of economy. Every country is buying economy. They do not want to talk of COVID, they want to talk of economy. They know it is wrong. They are opening schools, they know it is wrong. They are opening industries, they know it is wrong. They are opening universities, they know it is wrong. Everything they know is wrong. Is that mean this is standard of politics? Means whatever they know this will harm, they do that much. Means there's another way I can say with psychologically is COVID before impacting people of this world has impacting minds of these leaders and minds of all those people, top people. That's a fact also. You take case of Trump, you can take case of Johnson, you can take case of many of our leaders, you can take case of European leaders, you take case of wherever you go, you'll find same thing. Same thing. Something else is generated so they don't talk of this. Like it happened in Sri Lanka. A criminal has been sworn an oath of the MP. They want some topic to be elsewhere. There's no topic. You don't talk of COVID, you don't talk of something, talk of something else. So just like Europe, this is here, there is some talk of Israeli relations. But I'm saying there's no meaning in that. If you bring politics into place of COVID, you're just trying to run away from responsibility. So these problems are very old problems, and these will take time to solve. But COVID is you have done everything in your countries, but you are not controlling it. So all these 6 Gulf states, they failed. All European states, 27, 20 European states have failed. All America, 50 states failed. Our super failed. And you can say, if you go to Hong Kong, it failed, China failed. And this tell me one country that's successful. No one is successful. Just claiming that we are successful. So that's why I sometimes laugh on this. Believe me, I can't stop that. This, of course, this is seriousness, but laughing also is a part of seriousness. Sometimes you are in so much trouble and you start laughing. There are no other ways of laugh. Because I can't do anything, so let me laugh that I can't do it. So this is my expression of utter negativism, that sometimes you laugh on yourself. Oh, what a wonderful mistake I have made. I'll come back to engineering now. It's enough for coffee. I want to continue the more. This engineering talk or this coffee talk. Coffee is more important actually, but we have to be limited in because of we want to discuss something else as well. So I was not very interested in COVID, but because circumstances compel, that's why I'm talking. And I tell everybody, young or old, and I feel angry also, but they don't listen. I don't know what's the reason behind that. A society, and everybody is there in society, they must be respected, but they should think also. And that's why I say thinking is my power. I use this thing in my title. Think. And I say engineer. Engineer is you can say power of thinking. Medical is a power of thinking. And wherever you do professionalism, that's power of thinking. And thinking means it's your key, master key. Master key that you have is thinking. Master key is that you have the dedication. Master key is that your commitment and concentration. No success can stop coming to you if you have will to get that. Will, W-I-L-L, will, determination. If you have that, power of soul if you have that. Because power of soul is everything. It gives you energy, it gives you determination, it gives you direction, it gives you, yes, I have to do this, focus on that, concentrate on that. And it energizes your body and it gives you health development. It gives you less sleep, it gives us a power of soul. We may not accept that. Your acceptance or non-acceptance does not rule, does not claim that it's controls. Soul is there, and that's why I'm talking to you. Soul is there, that's why I'm living. Soul is there, you are living. So that soul is a part of God. That soul is a node of God for you. A node we talk, so this is a node of God. And that node you must understand. You should think that do not depend exclusive on text-based education. Depend upon, use that text for, through refine that text through your, this instrument that's called mind. This is a structural mind. There is another power in this that's called soul. This is structure, this organ of my body. This is not on itself work. This doesn't work on itself. There is some electrostatic current, electrodynamic current, electromagnetic current which works here, and that's called master of soul. And this spreads all over my body. There is a systematic entry and exit of this, and that's what I have to think of the problem. And that's where I can find solutions. Problem is we do not believe in this system, and that's we say we are going on research. So real points will never come to you. Once you add yourself, no, it's my system and God has sent to me through this post office of magnetic world, I'll get answer and I'll get answer. And try it, scientists will get answer. Don't worry. Don't think what people are talking about. Soul is within you also. Soul is within dog and cat also, all other creatures. That's why all we are living. And that's where engineering is related to. Again I say every structure we put in soul. You do not know when it comes into this, but it is. Because soul is in material, soul is in air, soul is in structure, soul is in everywhere. Building performs, we ourselves say, the building serves. If building serves means there is something that serves. There is something that keeps intact forever or for until it leaves. So we have to think that way. I heard something that for 1,000 years some material is required to stay. Means this is an imagination for 1,000 years. No, there is no such, but it can be thought of. It can be made. It's about there's a temple construction now in UP Ram temple, and there's an idea behind it. It should stay for 1,000 years, and if you want to get something for 1,000 years, this means you need such that material, but that is secondary material. First, you have to see what is position of soil, and soil should be investigated, which is nothing. Nobody knows in that. It requires investigation, and this is not professor level investigation. This is professional level investigation. So some professional laboratory should do it like that in every project. So I think that material can also be produced. This can be thought of how we use concrete, what we use in concrete. We know that technology, but we cannot guarantee how long this concrete will stay durable, safe, without any, and whether it cause of hysteresis. Hysteresis is basic property of material. Maybe you know that, I'm not sure. Hysteresis is continuation of loss of testosterone or resistance on this body mass material. That's property in material. We say this material is resistant to this, is resistant to erosion, it is resistant to this, or it's very strong in this or in that property. But that property, that is power of that material also degrades itself gradually, and at some time, at some time 50 years or 100 years, there's some other resistance in that. Original resistance goes, and also its structure changes, its composition changes due to various factors of environment, factor of air, factor of heat on this, applied on this, like that. It loses something or it gains something else. This happens. It gains metamorphic action on that, or it loses something else. This keeps on moving and moving and moving, and you know that a time comes in metallic world or radioactive world. At last we get lead, radioactive lead, which does not move further. So we cannot say that, we cannot guarantee as today in engineering that we can produce a metal, but you can make it better and better and better. And that is what think of this means, how can you do better concrete? What is best way for that? So you can start thinking on that. In concrete technology, how does it work? That might you have to understand. Concrete, let us say, just for information's sake, I'm discussing with you because this point came to my mind last evening when I saw that news. I read that news that they want this something better than some other material which can stay for centuries, and well, that I cannot say it. I can give you that with guarantee, but a thought is to be applied that I put on that post. Please first try to investigate soil, and for that you need a professional material testing laboratory, and that we don't have here, I'm sure. Those standard laboratories we don't have. It's not people or no staff only you need. Means you must have that type of instruments, that type of equipment which can do this, and there are various laboratories, and because in Gulf countries this is very common, very common activity, soil investigation, because even for a small plot they investigate soil, and that's beauty of that area. They do everything professionally, and I am also experienced there. I have experience of Gulf about more than 20 years, and I know what happens here. I go to many reports of those, and I also shared some report with the structural forum of this country also on this Facebook videos. And so I can say that first we have to investigate soil. That's very important part of whatever building you construct, whatever structure you construct. So it's not high rise, even then high rise or low rise doesn't make a difference. You have to conduct soil investigation. That is basic requirement. Like you have to see what your body is. It's investigation you have done before your surgery is done. That way, when you construct some house or some building, it's your functional duty. It's your first duty to know on which soil I am going to site this structure, and that soil has what kind of nature, what is its porosity, what is its permeability, what is its bearing capacity, what is its can say the gradient of this and of that. We have to know what is the structure, how does it react to water, how does it react to its own way, or how many soils are within the one type of soil. All this you have to know. Bearing capacity, electrical resistance, thermal resistance, and water mobility, and how liquid limit, you can say Atterberg limits like liquid limit, plastic limit, semi-solid state, solid limit. That we must know what is required according to engineering position. And if you know that about soil, we can assess maybe this site is good for that, or possibly this requires some kind of soil improvement or making existing soil better. So that exercise is much more important than just thinking how to produce concrete first. Concrete is second part of this. First, if this soil must stay there for 100 years, if that's first question, and maybe it's a seismic area, so you have to be much more careful that in seismic area what happens, and maybe it is sand soil, or it is clay soil, or it is something else, or it's the rock, means you have to go down and see. It's not that you just go down 5, 6, 1 meter, 2 meter, and you decide on that. You have to know what are many layers. We can say up to 20 meter what is there, up to 30 meter what is there. Even if it's 2 or 3 story building, if you want that durability of 1000 years, and you have to understand that this soil is also that level first. What is water table there? What is that? And generally water table you find at 3 meters or 4 meters or 5 meters. You will find that because somewhere river flows here and there is sand soil somewhere below. Particularly you can say sand is available in bottom of river, maybe about you can say 10-20 meters. So if you find soil that's because of seepage, this is not sea, this is not basaltic area, so water can penetrate, water can pass through porosity, water can pass through your permeability power of rocks or substrata and can reach your area. So water table rises there, and that's your point, rising water table is there. Your bearing capacity itself is reduced to 50%. And if it remains there, you cannot depend upon whole bearing capacity. And this is where you can say geotechnical information is required for whatever area. And that geotechnical information is soil investigation, while soil survey below, practical survey, not just imaginary surveys, N value or C value or whatever value, you have to ensure that. And that's called, this very simple, I'm telling you, you have to take out course from there and to see what is the rock quality designation of that soil, and you can, what's the recovery of that one, and how good it is if you test it on site or test in laboratory. You must know complete details, what's the, you can say, optimum moisture content of that soil, and how it can be, or how can we improve it if it's required. Maybe you have to improve soil before going to building, and that information is not at that stage when you are starting or you are starting. So that is what engineering says, that's what mechanism says. But we should understand, I'm sure there's a problem in our country that everybody is a professional. That's also good, everybody is a professional. But profession must be there. That's important, means update must be there. I'm not saying we don't know, we know everything, we're very brilliant people. I respect people of this country, but they should be serious about that. Just assuming something doesn't work, First of all, it should have been done before, much before soil investigation. How does soil behave? How does, I say, soil talks to you. If you want to talk to soil, just like car talks to you, car talks to you through its voice, through systems, vibrations, and just when it happens with you, you talk to yourself by your vibrations, sometimes you talk to yourself. That way I say, engineering says soil industry first, and then we think of concrete, means what concrete we should have. When we want very, very durable concrete, we want to use this concrete for 500 years, 1000 years, then you should protect it from impact of soil, from impact of water, from impact of something else. You have to not only protect its impact from substrata, you have to apply that also. You should provide protection for structure, and that protection is important here. Protection from soil chemicals, and protection from water, and protection from environment, ingress, protection from chloride penetration. Because there may be chlorides in air, right? We cannot until we do chemical testing of that. We cannot watch there. It's just the water is there in air, nitrogen is there in air, argon is there in air, and there could be something else as well, depending on the location of our area. And if chlorides are there, then question rusting is very important point there. Rusting will happen and you will lose the strength. So how to protect that one? There are so many ways of that. One way is that you have to protect first of all steel in its original form, and then using same, or otherwise you use some other form. You use epoxy coated steel. Epoxy means doesn't allow any water penetration into concrete, and steel as well. And with epoxy is a good material as far as weather resistance is concerned. You can say water doesn't harm that. So you can use epoxy coating, or other one is you can use stainless steel bars, which is I think not available probably. Of course it shall be very expensive. Use 316 or some other else, but it will be for long duration. It goes into concrete. Other one, if you use epoxy coated parts, you have to see this reduction of maybe bond and overlap you have to increase, and like that means what I'm saying, you have to think of concrete also. What kind of concrete you want to use? Concrete we generally use structure is around 13, 35, 40, which is ordinary aggregate. Let's use a lime aggregate, and rock dust, or they say coarse sand, and ordinary cement we use. So that's ordinary concrete, but this is not case of ordinary concrete. This is a case where we want to use it for 10 centuries or more. So you should have different kind of concrete, and of course concrete ingredients are there, but you have to try to make some sample, make some trial, and that's first of all you have to increase density of concrete because you want to stitch hardness or strength of that. Means if you want to make, you can first of all increase density. Think about how to increase density. General density is 2.4 tons per meter cube, which can be increased by what method. You have to see what method can be numbers lesson for that. I studied long back about that, and just in very short from that. We should want to densify concrete, want to increase means weight from say 2.4 tons to let's say 3.5 tons or 4.5 tons or 5.5 tons, and we should assume that what's density of earth material here, that's up if just go from surface downwards to say about 35 kilometers, immediately you will find density of say 2 tons to 2.5 tons to, on an average it's say 2 to 5. 2 to 5 is your crust density in which buildings are constructed. So 2 to 5 you can say about 3 tons or 4 tons. 3 tons per cubic meter is our earth crust density, let's take that way. And so how to get that density of concrete, which is by nature when you say it's about 2.5 tons per meter cube, and when steel is mixed with, so it may be called 2.5 tons per meter cube. This is our natural density when you use ordinary concrete with say 300 kg of cement or 350 kg of cement, and aggregate is about 1800 kg per cubic meter, and sand is also about same, and we mix in certain ratios, weight ratios, and 0.44 maximum water cement ratio. So we say this is concrete of this grade, 40 grade, 35 grade, whatever grade is that. We say that's okay, that's fine. We depend to design on it. Here we have to increase because durability is required here. Strength is okay, strength is fine. I'm not talking about strength. Strength is one part, but durability is another part. So if you add something to concrete and protect its surface, I think it will help, and that's what I say. Let us say we add something to that which augments its density. That could be steel shards, you can say, broken steel, pierced steel, or steel that is in powder form, which steel is 7.8 or 7,800 kilogram per meter cube. That steel, if you replace with aggregate, say, we take half aggregate removed from there. If we take out those 20 aggregate, which is about 0.85 cubic meter or 0.84 cubic meter per cubic meter. This is per cubic meter, which I say per cubic meter is 2,400, and you say 0.84 or so 0.85 cubic meter in that is an aggregate. So 85% of that. So 85% of that, and if I take 85% of that means out of this 2,400, let us say about you can say 85. Let's it's say 16 or 1700. Let us say this is weight of coarse aggregate, and if I out of this 500, 600 or 700 I take out, or half I take out, replace with steel powder steel like that chips. So I add something, I can increase weight of my concrete. It can be more weight. Let's say we increase the weight so by 50%. So this is 2.4 by 50% increase means 1.2 goes to 3.6. So if you try this way and get up to 4 tons per cubic meter, or let us say 5 tons per cubic meter, if you get brick to that, because weight of steel is 7.8, so it's about, you can say 2.5 times to 3 times the weight of concrete. So if you say use half of coarse aggregate and half of, so you can say up to 4 or 5, you can produce a concrete which is in middle part of earth weight, that is 5.5 kilogram we call average weight of mantle of earth, mantle of lithosphere. So let us say I produce a concrete of 5 tons per cubic meter. So I have taken double now. This means I'm going to use steel shards, and these steel shards of course will add to compressive power of concrete. So I can use it in a better way, not because for providing bending moment, but for providing something else, and that is the durability of that. Steel is through uniformly distributed in uniform homogeneously, that's homogeneously distributed into grain concrete or wet concrete. And then let us say another production required is that water should not penetrate into this cover of concrete. Cover of concrete means where portion, that is surface of concrete or column concrete, for example, or foundation of concrete, whatever is taken from surface of concrete up to up to steel surface of concrete up to steel. And that's point to consider, that point is very important. That is surface of concrete, external surface of concrete to steel bar. Steel bar means not main steel, even you can say ring of that. So we have to think of that, up to how many millimeters of water penetrates into that cover. We call it a concrete cover. We call it, this is certainly we call cover, and we also call it spacer. So how many millimeters or microns that water goes or enter into that surface, and is in how many, in 1 year how much it goes. So depending on that, how many millimeters it means in so many years, because it will dry out also, don't forget that, because there is a thermal application of sun, there is a wetting by moisture, so moisture evaporates also again. So what is the remainder there? So in how many years it will affect, it will penetrate cover. So in case generally we take where there's humid area, we take cover of column about 4 centimeter, 40 mm. We take cover of foundation say 50 mm, and we consider cover of beam about 30 mm, and cover of suspended slab 20 mm. This is general in ordinary way, but it's not necessary that you adopt that. Keeping 2 points in view. One is fire application, if there is impact of fire. Example, application of thermal load, that's due to fire. Fire is an impact, thermal impact for hours on a structure. So that portion is heated up. That portion of cover is protection of steel, protection of the internal part of concrete. So that cover, this heat transfers through that cover. It's 40 milli, just because when heat is there, fire won't reach foundation immediately. It will affect surface of slab, it will affect sides and soft bottom of beam, it will affect your column. So there, wherever first comes in, first exposure is there, immediately, which is exposed surface, the environment exposed surface, the air exposed surface. Even though there's a plaster on that, yet plaster is not that strong that it stop fire. So plaster immediately crumble. Plaster is for protection of moisture only, not of fire. Even if there's a lat in that, you cannot say, yes, there's one point, so you can apply some epoxy coating. Epoxy coating you apply, that can, say, to some extent, it can prevent, moisture entry. I'm not talking fire still applies on that, it's like plastic, it's chemical. Epoxy is also a kind of a grade of plastic epoxy. If you consider, chemical carbohydrates of that, if they have formula CH3, etc. So it's a plastic material, epoxy. Epoxy is a higher level, you can say high value, or can say high performance plastic. So that's plastic which can stop water penetration, but it cannot resist heat. So fire still applies there. So now what to say in that case? To augment or to strengthen capacity of that surface against fire as well as against moisture, and that is to increase what we normally take. And we normally take, say, we take column 40 millimeter, so we will take it 80 millimeter. What's the problem with that? So that it is double in cover wise, but in penetration of water it may take maybe it doesn't allow that, because if we apply epoxy coating and we maintain that forever, and thick epoxy coating you apply on that, there is no question moisture can move through that. And that's where means we can increase already, and we use dense concrete for that. Dense concrete, where it is used. Dense concrete is used in where we high density concrete is high density concrete. There are two types. One is high density concrete, when one is thick concrete, means thickness of concrete is higher. We mean members, we take thick members. So density is not important there. Thickness is what, that's like you can say in nuclear reactor building, where gamma rays and X-ray those apply, and which can penetrate low thickness. And when density is higher, or you can say even thickness is high, so those rays also think of once again how to do that. So what I am saying is, it's my only technical thought assumption. There's no book answer as such that how to increase that. So I can only think that first of all we should increase the size of cover. Means we have to increase this overall size of members. Maybe slab is there which can increase, so 40 mm, we can say 80 mm or 75 mm column cover. We can take beam, 100 mm column cover, I'm sorry, and 75 mm or 80 mm beam cover, and 40 mm slab cover, and say 100 mm foundation cover. This will help. And we use as high density concrete, as I said. So what shall happen in that case? To some extent, you don't worry about stresses. Stress calculation is not, I'm talking that. This is not very that kind of building. This is just an ordinary building, but its life is required. And so we have to, how many solutions we have? Number one solution is question about soil, and that is whether existing soil, whether or not this is applicable, this is good one for this design, this is valid for this design. And that can be known only after investigating bearing capacity or investigating shear value of soil, all that we know. And if so necessary, we can increase that bearing capacity, and that can be done by removing bad soil if it is there, or stabilizing existing soil. That both ways are there. We can stabilize also, or we can remove and put granular soil, perfect granular soil there, so that there is no need of consolidation, because consolidation is a very important part of every building. There is a direct relation between building and consolidation in long-term action. You can say compaction is immediate action, we understand that. Those people who are not clear about it, I like to repeat that compaction is packing of soil particles. Soil is mineral, in fact it's natural material. It may come from rock or it may come from somewhere else. It's a package, it's a structure. Soil is a structure which is more important than your concrete structure, with structural framing. It is a structure because it supports on its structural framing, so it's more important than your structural framing. So if you understand soil, if you pack it, packing is imagined, it's like a boxer. This packing holds your building. It holds a building at one level. It supports your building to stay with you, but gradually it's further packed. When you do construction, at that time you pack it. It's remained packed, but not 100%. It's packed. It's packed up to 98%, 95%. Still there's 3% or 4%, 5%, or maybe more. Maybe it's more compressible. It can be densified up to 110% probably. In that case, immediate packing is very little. It seems it is packed, and we are satisfied. Okay, 98% packed. But still say 110% it could reach. So say 12% packing, it will take automatically 112%. That's danger here. It may take 12 years, it may take 20 years, it may take 50 years, 30 years, who knows? And that's the point where we are talking, and that's called consolidation. Means there was solidification when we compacted it, but further solidification continues automatically because of load of building, because of water mobility into foundation, soil water mobility, because of moisture ingress, because of chemical effects. Something is down, something is up, somewhere solution, maybe there's some solution of that soil with water, or there may be some chemical change of structure, whatever be reason of that. But Continuous loading is there, don't forget. Continuous load of building and movement of building, not simply direct load. You cannot say the load down. No, no. There can be momental means building is in fact dancing. If you just imagine, you say rocking. When the earthquake affects the building rocks like this, like this. In these three directions, it moves like this. So that it's not rocking, it's statically, it's moving of that. Soil is there, soil is affecting it. It does it. Believe it or not, it does it. That's why we calculate bending moment and we see what is the moment of resistance. We calculate thickness of slab. Based on that, we can calculate column size. We provide steel according to that. This is complete calculation. Bending moment. We say hogging, sagging, and we say, deflection, and we say reaction. There are so many forces we consider when we design buildings. This may not be clear to common people, but lot of work is done before building is allowed to be constructed. These forces act on building without stop. We say dead load, we say live load or live action, we say transient load, we say accidental load, and we say permanent load. Like that, we say building decaying, building losing its strength, and we say building is such a stage that's called plastic stage. Building is such a stage that's called yield stress, where it can come to constant. Yield means, I mean to say, let us say I beat here, it goes down, this book goes down. I say my hand is there, it goes down, it comes back again, it goes down, it comes back again. This is elastic stage. Elastic, you pull it, it comes back. You pull it, it comes back. That is elastic. But if suppose you pull it, it doesn't come back. This when it's permanent change. It's a permanent change that, and you further pull it, it's in stage plastic stage with this no more semi-solid, solid, and then it breaks. It breaks, you can say collapse. So that's what I'm talking about. We have to investigate all this. So when I say building is on fire or building is in moisture free, when moisture goes into that, what happens? There is a steel element. If the steel element is near surface of concrete, water reach there immediately, or say within 1 year, 2 years, it goes a little, comes back, goes a little, dries out, goes a little, dries out. Same thing of fire also both ways. Fire is there and water is there. One time fire applies, fire occasionally applies, I can't say regular, but water work is regular. It may be internal column or maybe external column. Internally there is humidity, water goes in. Externally the direct water goes in. However you can put dehumidifier or whatever you do, that doesn't work that way you expect. It's a permanent work. This forces are 24/7. Yes, live load may be drawn for the night time, but permanent weight, dead weight is there. So building functions 24/7. That's point we should say is very important to understand. So we have to first of all apply consideration on soil investigation. Then we have to increase concrete space or thickness, concrete cover thickness, and then you say you have to use a kind of concrete which is high density concrete, steel short seam, and you can replace OPC up to 70%, so that this is low reaction concrete and it doesn't cause any cracks. So there are so many, and then you can use microsilica or GGBS. Microsilica is better if you use, because this is expensive but this works very well. Or you can use GGBS. If you want to imitate good results, you can use 10% microsilica. Even when you use OPC or you do not use GGBS, so this microsilica you can use, or you can use GGBS. You can say granulated ground blast for slag cement. PFA can also be used. PFA has a limited power. It's not very extensive metal. It's not a widest scope, but GGBS has widened. There's a GGBS can be varied, can be controlled. PFA is controlled, is confined, you can't change that. So there are so many technical points we will discuss in this And this is common points, means even common people can understand. When I say PFA, everybody knows this is a pulverized fuel ash. When you say GGBS, it's a ground glass blast furnace, granulated blast furnace slag, and we say microsilica, that's silica fumes. And these are all very common materials, and they can be used. And previously we used to SRs, SR is not used, that is sulfur resistant, no use, because GGB has the same power as sulfur resistant cement, and also its power that reduces cracks, and because it takes time to setting, it starts delayed reaction, and that's why I say we call it low shrinkage material. So high shrinkage materials, OPC is very high shrinkage material. If you use OPC, then you'll find immediate cracks, because very fast reaction of heat happens here, and reaction is very fast, heat generation is very fast, and fast heat generation goes against production of concrete, and we have to take many care in that to keep it cold. Otherwise you can use GGBF, which is GGBS, or you can use microsilica, and that depends upon you. This is nothing new in this means we have used in our all projects use it. It's not something new. I used microsilica in 96 even. You can say 96, you can say 24 years back. I was in Doha when I came to know microsilica is used in this 8%, 9%, 10%. It's used, so it's used, we know it. This is silica fumes. Silica fumes means the silica is nothing but your soil, like sand, soil, where it's very, silica fumes means it's very, 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 you can silica like clay. Clay is much finer than silica. Silica is second form of that. Clay is 0.0002 mm, and silica will be 0.00, much coarser than that, but finer than sand. So that silica that I'm talking is, what it does, it like cement, like smoke. When you smoke and release that smoke, that particle is like silica, microsilica. Micro itself become much more smaller than that. So what happens? Cement particle is very fine, Cement is very, very fine, but this particle is so fine that it even coats that particle of cement. So this coats particle of cement means that surface of the spherical particle of cement is coated by this fume, and this keeps that particle apart. See, beauty of nature, beauty of material, what material says, what material does, means we know that it does. This silica fumes goes there in gaseous form or in smoke form and coats every particle of cement. So these all keep apart. The volume is same, but these are not together. There is adhesion in between each particle rather than cohesion. And this adhesive arrangement between particle of cement and smoke, this silica fumes, keep them apart even after being mixed with water. These are kept apart. See that how powerful is that adhesion, power of adhesion between these two particles, cement and silica fumes. And until we apply vibration needle onto that, this bond is not broken. This adhesive bond is not broken. So that is beauty of that microsilica. It keeps your concrete apart even up to a couple of hours. For example, you immediately late now. You don't vibrate. It won't work. It won't set in. You can wait by mistake if it does, or there's some problem. You can hold it until you apply your vibration. It won't. That is microsilica, but it doesn't apply with GGBS. GGBS is not that adhesive power. Keeps it out. Its power is that this low heat material means it doesn't give complete reaction immediately, part reaction, and it takes time in its total reaction. OPC gives immediate reaction. That's why we have to say that within half an hour it starts a setting time. So there is such development in concrete. Still this going on and on and on. So we can use these techniques to increase as much as possible our structure, though it costs. But if you say no, I have no concern for cost, I have concern for reliability of this material, and reliability also includes durability in addition to safety and performance or service. So durability is your demand. That demand can be mixed and be met by this, and that's where importance lies. So what I have to say, that it's thinking that gives, there's no book, there's no answer for that. but experience can give you something. It can be tested, it can be conducted in a trial, and you can see what difference comes in strength, what difference comes in permeability, what difference comes in water absorption. That can be checked. What difference comes in chemical composition, what difference comes in stresses and strain, what difference comes in the tensile strength. All this can be worked out. It doesn't take years, it takes just a question of 1 month or 2 months. So if you mix that, if you get that one on 7 days and then on 28 days you test it, certainly you may test it on 56 days as well. It depends upon you and you can find answers. So this is not a question that will take 100 years, it will take a couple of weeks if you want to do something like that. That's engineering. Means there are so many ways out, and engineering means that chart out solutions. Means you must have faced problems because you are engineer, and it is duty of engineer to receive problems, to analyze problems, and then you understand completely how you can think, you can do it. You think on that, and you're thinking once or twice or thrice or fourth time, certainly you'll get something. You are not blank, you already have information. Every engineer has information. That information, but we don't use that. We never dig it out and think on that. But when something comes in, we have information. We have information of theory, in form of theory as well as in form of solutions. So we can think on that. We cannot simply say it applies on intellectualism of or the intelligence of engineer. We not count. But we have to understand basics. That's more important. Why we use concrete? We understand that also. What is purpose of concrete after all? When we are using brick or using stones, why we know reasons of that. That's why it's nothing new that I'm telling you. You know it very well. Only thing is requirement is, when there's a requirement, there's a question of thinking, and thinking is research or re-understanding of that, or reviewing everything which you have done so far, where we failed, where we learned lessons, and we don't have record of learned lessons, and that's the problem here. This new generation means they need some documents, and there's no document at all, and that's also a deficiency. When we are talking something, we should record that. Why other countries are successful? West countries are we because they maintain documents. And we do not do that. We believe, okay, no problem, let us see. That's our culture. We never had any written. We believe in words, and they believe in words as well. But written is written. If you may speak, you may forget what you speak. Others may listen to you. They may forget to listen. But documents are documents. You cannot change them. So that's what engineering is all about. And I should say to everyone, don't take it for easy. We are not here for seminars. Seminars only for interchange of knowledge or interaction. We should not say that this is everything. Every work is important, and every principle is important, thought is important. Maybe I'm not talking so competitively or so consistently, but what I am thinking, I'm not. What I said, I did not do that. But I read that somewhere, very superficially, of course, when I was doing my interview. I still recall this question was asked by some interviewer, British interviewer, long back in '95, I think. In '95, I was there. In those days, I had no computer, nothing. Just I typed on my very bad typewriter. Once I took a small typewriter, and 30 letters of fonts on that, and I used to write applications and submit to various companies for appointment for interview. So once I was interviewed by English interviewer, I didn't know which post I applied for, just went to an interview, and I think I never expected that person would interview for 45 to 1 hour. I appeared in the same interview twice before, but I could not qualify because I was not having practical experience in those days. In those days, some Arabic engineer asked me, "Do you know heavy computer, heavy structure, heavy foundations?" I didn't know what it mean that time. I said no. So I knew it, but I didn't know what's talking about. So it happened, I think, twice, and I could not do that. But this time, I don't know, by chance or this interviewer, British, I thought maybe he's very intelligent, he'll ask many questions. Yet I appeared, okay, now I come for this, why not do this chance? And my personality, is very poor personality, not very impressive. and not wearing tie and not just going for interview, sit down. Maybe he thought I'm just useless person, but when he's looking at my CV also, he might have said, this person can't be engineer. But then started talking to me, and he continued asking and asking and asking, and I continued replying and replying and replying, because I had experience till 95. I had about, you can say 10 years, 15 years total experience, but many years of overseas experience till that time. And I used to read books, ordinary books, engineering books, particularly engineering books, and I used to read them. And I was also at that time, before publishing this book, I say civil engineering book. That book was also in press at that time. So he asked me many questions, engineering questions, and I was good in answering engineering questions because of my habit of reading theory. I mean, not numericals, reading theory is by habit, because numerical takes a long time and it holds you, and nobody is doing numericals in field, right? But theory is very important. When even on sites when I'm there, I have some spare time, I take out these specifications and read them. Irrelevant to it is civil, I don't care. I read if it's electrical or if it is mechanical, I go for something I get out of that, because I have done both subjects with my education. I have done electrical engineering and I have done mechanical engineering. We have passed that. Even in diploma and degree, both, in diploma also I passed electrical engineering and mechanical engineering. And I did AMI, IEI, there also I passed both. So I can't say that subject is foreign to me. Yes, I'm not expert because that's not my field, just a kind of awareness, the kind of awareness we have in interactive subjects, civil engineering, mechanical engineering, electrical engineering. So if I find some information like that, HVAC information, or chiller information, or some other split unit information, or some other information about mechanical, because in buildings only HVAC is more important, or chillers are important, or you can say package units are important, or you can say ducting work is important, or you can say something else, some treatment plant. Otherwise, not machines, you may say that is not that. Somewhere switch gear and transformers are there, and you can just go through that and see what it means. That information is so. Likewise, civil related, I used to. That is my line, so I can understand much better than. It's not that I had to qualify some degree, just for awareness, just for knowing what's happening in this world. So I felt what I could learn from those studies, those informal and secret studies. Secret in the sense that I didn't ask someone to took book or specification volume and go through that. At that time, they don't even have computers to use. So that in those ways, I can say I could answer questions what he asked. I think he asked about 40, 50, 30, 40 questions, and theoretical question as a practical question. Same thing he asked me about this question of how to high density concrete produce, and what you do. So I tell them both high density and high volume, both. There is high volume concrete for reactives, and high density concrete something when you strength. So I tell them shots are used. He kept this guy is telling about shots, now he told me. So I just threw it. I read in some one paragraph only. Still shots can be used, but we can analyze that. That's not big deal. So you know something. So I saw that when I was in office, I was by chance going through files. So I took my file as well. When you see his typing skill is very bad, means his CV is very bad, but his English is good, and his technical knowledge is very good. That's what he wrote in that. And he appointed me as office engineer. And I didn't know what was office engineer. That time I came first time to know what's office engineer. So office engineer means you work in office for all office activities. And I was not used only for office, keeping in view my capacity, my proficiency. They used me for office as well as for site, both. So I didn't mind that. This question was always asked me whenever I use assignments, particularly in this ethylene plant. My director asked me, what do you want? Where do you want? Well, he was not happy with me. I was not interviewed by him, I was interviewed by someone else. But when he asked me, where do you work? I said, this country, in that country. So he was impressed that I have some Gulf experience, Iraq experience, Libya experience. So then he told me, I like you because you are from Doha experience. That's why I appreciate it, otherwise I will send you back. He tell me, where you are work on site. He asked me at least 4 or 5 times in mass memo there or somewhere else. I told him, up to you, up to you. I simply know, up to you, keep in office. So he could not decide. So okay, he then discussed with someone else. Okay, send him to site. He just sent him to site. I worked there for more than 1 month, many projects, and then I dispute with those people. So you have disputed, why you disputed this and that? So they transferred me to office. You go in office because they thought they felt they consider that I was better in office than on site, because in office I would not fight with someone else. Fighting was a problem for that, and they needed some person to work in office as well. So he circulated information to everybody that this is a responsive job description of this person. That way means I guess. So about that I'm saying I used to go through many specifications, and actually I had no time there, to be very frank. In those 3 years in jungle, in desert, on the plant, I had no time to think, just work, and work. And I enjoyed that too. I just started at 8 o'clock in the morning. I used 8 o'clock or 7 o'clock, whatever time I started. I reached early morning just to see something else I can do. My hunger for learning never stopped. Still now I am hungry for learning. That hunger is such high volume. I don't value it to degrees, because there is a limit in degrees. You can't do more than that. You won't be taught more than that. But the learning has no limit. That's why my principle is learn if you can. Don't worry about degree. Degree won't stop you from moving ahead. When people see that you can work, then degree keeps aside and you are given work. That's more important. Degree can help you to some extent, but your knowledge, your performance, knowledge and performance both are there. It's not simply knowledge. Performance is important. If your knowledge is there, oh, you are capable, I'm a doctorate, I'm this, okay, that's very high value welcome here, a doctorate or that. But you do something that's more important than. Means you just keep in your mind, I should be given this kind of job, because you are not used to, that's not your fault as well. I don't blame them. If you are having so many degrees, doctorate degree, master's degree, or something like that, then you will not like to work in field, in practical field. Though that is wrong, I don't accept that. But this is general tendency. They think they are having different kind of education and they should do different kind of work. That's their analysis. But I have seen people. I have seen people in Arab world, in European world. They are high qualified people. They don't mind. They work in field, and that is capacity. That is called, your principle, that you don't mind working there, and that's very important point we should say. I respect those people. Yes, I don't mean that you don't go to office. You go there as well until you learn on site. You can't guarantee what you learn is right until I don't see concrete how it works, how it is done, what problems are there. Until I do not realize that, I can't guarantee what I learned is right. I can't certify myself. I can't verify myself. I can't corroborate myself. I cannot ratify myself. Whatever learned is fine. So once I experience that, yes, I learned this and this is performing, I know then what is material when I go to site. I know how work is done. I know how documentation is done, which I cannot know in my university. It's not possible. So when I know that, I understand that, I perform that, then I have every right to amend that also. That right is automatically given to me because I use that document. When I can change that document, or I can discuss with someone who has authority to change that. I can say we improve this one into, or I add some column to that, or I modify some column. That is permitted because you are a teamwork now. You are a part of team. Maybe you are heading or you are head. That doesn't matter as far as your performance is fine. That's why one performance is used. It's not single face use. Perform. You have to work every direction. And That is more important, where you can earn your living, not living, earn your more knowledge. You update yourself, you command yourself, then you are more qualified to analyze rather than based on degrees when you have experience, because there is example. There is no need of any guide. You are your own guide. Work is your guide. Documents are your guide. Your colleagues are your guide. That guide is feeding. That guide is the feedback you get in. Your own feedback. You get practical information from what? Not from imaginary and assumption information from your guru or your professor. So I what I learned is that you have to learn, that's it. You keep learning. If you have chance to learn, you keep modifying, attempting it. If you can, you have systemized your already working system to a better status. If you can, do not interfere system if you do not understand this. Because if you are not a surgeon of that system, don't interfere in this. What a level comes, a time comes in life that you start thinking that yes, I am now different. Next day say yes, I am different. After 1 year, yes, I am different. I am not same as I was before. I'm not same as I was in my first assignment or second assignment. So I means a boosting comes to you, a favor comes to you on your own, and you perform better than every time. So this is called engineering development, or you can say professional development, that you learn every year, you learn from every project, you learn from every every act what you do in engineering, and you get information from project also, interactive information, all information, whatever information you could not find, you may get through some document, because many writers involved there to make those documents. So engineering is that kind of a flexible word. We can change things according to the requirement by by trial or by testing and having support of that, and then impact on that. And that's, like I say, come back to compaction and consolidation as I was talking of. That's most important. Consolidation, you have to produce, you have to determine power of consolidation there. You have to establish consolidation there. If you can establish consolidation there, forget 1,000 years until if this area caves in, that is different. That's I cannot answer that. This caves in due to whatever reason. If this earth exists, if lithosphere exists, if this continent exists, your building shall remain forever, provided you keep it improving, you keep maintaining and reform it, or you can say retrofit it whenever every 20, 30, 40 years. So it will be strengthened again and again and again. So it can move up to centuries even, provided you consolidated it. And consolidation is nothing. By soil improvement you can consolidate. If you remove say 1 meter soil and fill it with granular material, don't worry about compaction in that case, because compaction is required for compressible material. For clay, for example, for clay or silty clay or that clay, where there is chances of swelling and shrinkage, and consolidation is required for that. Once these are consolidated, there is no danger then, but consolidation is not guaranteed here also, because fluctuation of water table impacts again and again and again. So we have to be very careful. If it's granular fill, we can say engineered granular fill. I call it engineered fill because this engineered layers, not that we put in that, and surveys that this is conduct of novel forces and this worship shapes, all these are, of course, these are also body of world, but even then we have to see ourselves how capable. So if you can consolidate base formation level, and you just keep it consolidated and filled in that portion where your external building part and the fortifying induction goes to, it's covered in that one. There is no chance that your building can sink down, provided it's completely given good foundation, beam frame foundation. Piling is very expensive. That piling is okay for purpose of understanding strata, but not necessary to provide files if you are this mechanism, soil investigation. It is worked successfully, and that's where we need it. That's where we like it. So that's very important point is consolidation, difference of consolidation and compaction. So this consolidation is one answer, which is soil improvement, and also consolidation by filling, and or you may sometime you may use in some locations around this that there is no way out. I need some concrete because I could stay. I mean, this such soil on that portion. I can't compact that. But if you spend something on fill material, something on I'm saying few contents of these of 1,000. And so question is not that. Question is civil engineering, how it moves. Civil engineering moves like this, as I told you. So we can change a structure. The structural change gives us something. This point we should understand. That's just just for relaxing. I just now not after 10 minutes I'll take. So what I'm saying is, my dear friends, not for sake of talk, for sake of launching up mind. Means you have to launch something in your mind. I'm not saying launching on some bag into your mind, because I say your mind is very strong. This is only wealth of an engineer, that we use mind. Only profession where original mind is used is not even used in medical science. There is only relative mind, because information is available in medical science. In every other science, information is available, but information is not available in engineering science. Formulas are available, tests are available, but these do not apply everywhere. You can think and do whatever kind of design, but that is variable. If somebody else does, they will do something else. So it's not fixed one. It's up to you. We can advise people if required in this mode, but so it's interesting one to know that some people think of that their structure should be 1,000 years, and this cannot be only for that structure. It can be your structure as well. And if you want to do innovative structure, you can think of. People are not thinking because there's no demand. Thinking is no problem. Engineers have unlimited thinking. They have a power to think. If engineering is really civil engineer, we have to think in that category, and that's very important, significant, that we are taught to think, and we are not taught to think. We are automatically forced to think, because we have to devise formula, original formula by calculation. We have to form structural mechanism ourselves. Everybody does its own. If I do something, if somebody else do something, we may do different kind of modeling, but it will always be stable and in dynamic equilibrium, or whatever you say. Once you disturb that one, it will come to same again and again, but both will be different. What I do, it doesn't mean other one do same. So this is optional, we can say. We have to see how better we can do. That's more important rather than competing with each other. There's no means of competition. So I think this way what I thought. So I express to you what is my opinion, and that can be used or cannot be used, that different material. So engineering is that, means I have no limit on engineering, you have no limit on engineering. Engineering is engineering, and civil engineering is having many options, because we designs. We don't build, we get material design or machines already manufactured, so we make our machines on site, and that's beauty of civil engineering, which beauty we should disclose to people, that we design these machines ourselves. We produce bridges, we produce buildings, we produce canals, we produce dams, we produce railway lines, we produce roads, we produce airports, we produce hospitals. Everything means this is where civil engineering lives in. If this doesn't, if these structures do not, or development is not required, then civil engineers are not required, and that's why we are civil engineers. The beauty of civil engineering is that we are civilized people to make others civilized. If civil engineers are not there, people have to stay in jungles, in forests, or in unorganized way. Still, engineering is vast. People are living. You go to New York and see there is no uniform layout. You go to see Delhi, there is no uniform layout. all have hazard. You go to Bombay, you go to Calcutta, you go to any part of world, what part of world you can see. You even you go to Dubai, old Dubai, you will find hotch and potch. You see new Dubai. There's a difference here. So what new engineering is that you have to think on, you have to establish it, you have to plan it, and same way you have to plan in building. Buildings which are new one, which are well designed buildings, you all find a difference there in good ventilation, good everything, and also good structure. And if you can do that, that's fine. Every structure is new, and once it's new, once it's old, it depends upon its stage. And once it is old means you have to retrofit that. So retrofitting, again retrofitting every 50 years or 100 years. And if you want a structure for say 1,000 years, then you have to survey that. You have to engage some professional for regular use. Means every 20, 30, 40 years there should be some inspection. For example, roofing itself is a very big issue. Though maybe in that no, because this is a temple, but I'm taking general. Roofing itself is a problem in India. I am finding that problem. Roofing when I say, it doesn't mean slab. It means roofing, means finishing roof. Finish is where you can say roof floor. And this is very important part of structure. Because roof floor means if it's functional, if it's okay, it shall drain out water. Drain out means water should not stay there. But even then, because of continuous rains, and also season is that, or the weather is that, or you can say area is that. In Gulf, probably it's not that much risky, though roofing system they use, and I think rains very little, but sometimes too heavy as well. So I have seen those areas also flooded. Jeddah was flooded. So many other areas are flooded, even many height, because there is no perfect rain disposal system. They never expected it would rain as such, but it happened. We are in a country where rain is very common. So roofs, just like we say, state drainage doesn't work well even if it's provided. It's not because of drainage is not functional, that is because it's not properly maintained. If there is settlement, there's a sedimentation of soil, and soil is never controlled. It can come from anywhere, from whatsoever soil can enter all drains. Dust is enter everywhere. We say horticulture, we say arboriculture. We promote arboriculture as well. There's a plantation we promote. So those plants, those leaves, those all shall come to that drain which you provided for disposal of that. And if that drain chokes means you can't help it, water shall be stagnant there. It happens to my building also. I produce myself, my drains are clogged, and every time when I come myself and say, I clean those drains, because otherwise water is stagnant there, remains stagnant, and it pools up there. So that's what I'm saying, maintenance is very important. And all cities are flooded temporarily, not forever, because drains do not work properly. Then this is what you do, it will happen. So what I'm talking about, roof is same thing as a road, as a street roof, same. Your roof is not well drained. I mean to say, you cannot allow slab to drain out, but your drain itself, we cannot call it gargoyle, or you call it outlet, whatever you call it, means it does not work properly. And even if there is water downtake going to gully trap or somewhere, or you just leave it there on floor, it doesn't work properly. So your stagnant roof is filled with water. So we have to take that point also into consideration. What's the best design for roofing? Because roofing stagnates water, and that causes impact on building. It can come down through slab if it's not very dense, or it's having penetration power. Some slabs, concrete is not perfectly, it's 100% packable, or you can say 100% impermeable. There is some permeable, because after all it's concrete, human nature, there are pores in that, and of course there is not uniformity in that. Every concrete, all different benches are heterogeneous. They don't meet each other. Yes, it's one part, one member, one diaphragm of that building. That way, so we have to think into our consideration what's the best possible way. And also, client whose whose building is that, he must support. Otherwise, you cannot do it without that person's support with honor. So like that. I can say engineering is a different world. World doesn't say you can't go to that world. Means we cannot limit it to education world. Education is limited, but engineering is not limited. And when there's a pool of engineering, then you have every possibility. Though fast tracking has also built something, but fast tracking with expert quality and production quality inclusion, I think that's called professional engineering. Professional engineering is quality and quantity both are important. And quality is father and mother of material. Maybe it's a dry material, it's raw. You can say it's a material just supplied from rocks. Rocks are very important in this because we get stone chips, or you can say aggregates, coarse aggregates, which are nothing but rock particles, and that's very important because we use them into integrated material. Is a material, this material of concrete called concrete, whose definition we can say it's a mix of constituents, all are inorganic and very useful, and they are interlocked together in a sense to be called concrete, artificial stone, much more stronger than stone, and we have to research out this way to redefine everything, redefine how to produce quality, redefine how to trial and mix error, how to design concrete bricks, and redefine everything. We should keep on redefining because it's not necessary what materials we get today. Tomorrow, same quality material comes to me. There shall be movement of graph, this will change in curves every year, change in percentages of dust it has, changes in everything, so we have to keep redesigning. It doesn't once you have designed, you have to do that forever. No, that's not possible. The materials keep on changing. So there's the limit also defined on the codes. What's the maximum limit of your one design to use, and then you have use another design. By chance that other design is not available in time, then your work will stop and you have to arrange for something for them temporarily so that they can continue their work. Even sunlight is absorbed. Suraj stops supplying sweaters. It can't heat up. And also there are many other powers and you cannot go to the source every time. It's also very difficult. You go with them and do everything. So what I'm saying is engineering is not ordinary engineering. It's not school engineering, or it's not college engineering. It's not degree engineering. It is performance in field. It's like say artist is performing, actor is performing in field, so that you have to perform in field, and field means production field, or let's say execution field, or you can say whatever field you are in. Sometimes field is every day. We are saying for sake of field, and we in that case say this one. So my friends, why I spent time on this was reason that we have to think on. So I just replied on that post that this news came in about. They are sending some information, some request to IIT guys just to tell what class of competition is. And that's where these common people do not know that there is nothing as such. But they expect something, so you should give them something. That something is this, that these three materials we give our considerations, all other secondary, like school is secondary, lifts are secondary, hostels are secondary, and your talk is secondary, your walk is secondary, and that walk, talk, talk, and something that was fruitful, it should be fruitful, it should be valuable get out, and that's what we care for. So this is that. Just one point was there, but I took, I think, about 1 hour or more on that. This is natural because when you express something and you have experience of that, you keep on referring to that one again and again and again, and you reach somewhere. So I didn't know till yesterday what I would tell. And then I said, this is very simple, there's nothing else because you need durability of that material. So the very best is that in quality management. I think no company is managing quality. Whatever we are, means name big of a company doesn't mean company is professional. Every company spends something on research. Our companies do not do anything. They just want products. VATs, they are interested in VATs. They are not interested in social welfare, community. That is in the power of union. So let's move further on this. So this is one point. This I explained excessively also sometimes, I know, but access or not access, we have to understand. And once you speak, second time you speak, you also refresh that time. I missed that one by chance. It happens when your mind is very active. It happens if this happens, so you have to repeat that. It happens because after we watch I think when I think my eyes is somewhere else. When I read books, my eyes working more. Maybe I have color blindness. I cannot read very well. It's old book where it takes a very fresh eye and half eye. So keeping age factor being different, I can simply say that we should be active world, we should be intelligent world, and we should know what should be done. Only problem is sequence is important. If you do not live in sequence world, actually, those people who start at first profession, they think, oh, they must, when we get something from that person, we should demand is where the good comes from. What's the purpose of this whole world? And I don't know that, how it is. Well, it's okay. Means I talked yesterday about concrete and about soil. I don't know exactly when I said soil. I don't exactly remember what I was talking about the soil. Let me praise excuse me. See, I was talking about I will talk concrete otherwise. You can take it later on also. Soil stabilization now it's not that. This mind is crazy in my mind. My mind is crazy, so I think better we take something else. Hold on. I'm not a good teacher, you can say. I'm a bad teacher. Hold on, let me know water for a second. Take this one. Yeah? Who's there? Suraj Khapa. Why do these people want, I don't know. Some water is more than an hour. Oh, it's more 40 minutes. So I think water, I go to slab, I feed these will come back. I'll come back to you people. But I have the cup for 3 hours. And then, so really, I feel it. I send this list, this list of my audio, videos. I'll go there. What I'm saying is that I was talking about concrete yesterday, this section 5 of the Qatar concrete, Qatar specification. I was also talking about some soil. I have covered a lot of soil. I have covered many, theory in soil and also some testing. So I'm not going to soil engineering, but understanding of soil is important. I started with clay, I know. I started with, cohesive soil, and that is clay or silt. We started with this, what's basics of that, what's structure of that, why it's different, and what is the structure of that, how it works. Tetrahedral, octahedral, we discussed that. Octahedral, tetrahedral, square with tetrahedral, and this other one is octahedral. Discuss with that. One of the trapezium, square and trapezium, combination of these pages of books, how many in each, water addition into that, and between those units, and that's adhesive. That is separate water, but this adsorb water also. You know that adsorb water between these two tetrahedral, that water in this unit. And that water can increase and decrease, and that depends upon. And it increases in volume of soils, clay soils, and it decreases in volume, and that you can say shrinkage effects comes in, and all water goes out, polygon and cracking, you see on grounds and black on soil somewhere else in clay soil. That's a fact of that drying up. What is still adhesive water remains there. It doesn't go out. And that adhesive water is important here because we have to take out that adhesive water, and that adhesive water does not go by compaction, unfortunately. It doesn't go by compaction. Air voids can go on. Air can exist out. In compaction, only air is out. Very little water may be out, but actual water which is the adhesive form, that goes out only due to time, and that's called duration of consolidation. More and more pressure on that, more and more pressure on that, and either that water is evaporated due to heat effect, it's out. Generally due to heat effect, because in thermal effect down, when we test resistivity of soil, thermal resistivity or electrical resistivity, both we test. We know in soil investigation that generation of heat can evaporate those particles as well. That heat is available in hot area or in ground. If there is no water, it's dry, in the dry season, those particles too, those water particles too burn out or evaporated. And then only air remains and is goes down, and part consolidation every year. And sometimes we calculate that consolidation is so much in 50 years, that consolidation is so much in 20 years. There's a formula, empirical formula, not right one, can't be tried in this case. So in sometimes we say 50 years of full consolidation is there. Sometimes 30 years it takes, sometimes more it takes. And that is where we have to check a long length or long-lived building, a long-lived structure. The compaction doesn't value at that time. Compaction value immediate after birth of building, or you can say when building commission, it may take 1 year, 2 years, and that is 1 or 2 years. Some compaction is there. It's 100% actually, not some, but some consolidation may be there. You can say 1/5 or 1/10 or 1/20, but whole take time. At that time, it's where building may be cracking somewhere, it may be settling somewhere, or it may be sliding somewhere, and during that period this can happen. But once it is consolidated, provided there is no surrounding impact on that, there is no surrounding chance the water may move in. We call it soil water mobility. You must understand this point. What is soil water mobility? This is very big engineering point that engineers should understand. Scientists also should understand. Soil water mobility is some phenomena which cannot be tried mechanically or mathematically. This has to be understood in your imagination, because you cannot drive any size, you cannot measure what's level of Reynolds number there. It's up to 2500 or more than that or below that, because after all water is in laminar form. Maybe it is sometimes turbulent form, maybe it's sometime between we can say laminar and turbulent form. We cannot guarantee that one, as sometimes water level is down, sometimes water level is up. So soil, when water level goes down, soil dries up, and water level, even dry soil becomes wet, and water impacts the structure. If say sand soil, then it's porous, not porous, it's permeable, and that's dangerous also sometimes. Suppose there's sand below foundation and the water moves in, and if say its quantity is more, its permeability is more, it's dangerous also, because that soil which was consolidated, immediate consolidated, this again comes to expand, water goes in, it can cause problem. So water, though sand is very rare there, when question of the mobility comes in, sand doesn't work there, because water moves through sand. It applies in cohesive soil. It applies in cohesive soil means we have silty clay or clay is involved, and that's called cohesive mix. And that platelets, or you can say, what do you call them, dispersed structure or non-dispersed structure, whatever is there, that's badly impacted, and sometimes it breaks to, and when it breaks to this water, then water particles, water volume dissolves this broken particle with it and carry with it, because it's not very easy sedimentable, it carries with it for some length or some distance before it's sedimented, and then we can say that distance travel by that dissolved particle, that causes problem in soil below, and it can come to your foundation, or it can go from your foundation itself to some other area. So there is a loss of soil from you. So your compaction consolidation are disturbed. If it was consolidated, it is disturbed, or it was not consolidated, then it has to disturb. So intensity, which are in equilibrium sometime, which are in a state of equilibrium stability, that's the building was stable, is also impacted upon. So soil water is very important phenomenon, which is not given in clear answer in books, but should be understood by experience. I understood by experience means how water works. We cannot simply say bearing capacity of this soil is good, means everything is good. You can't say that. Or if the shear strength of soil is good, or its cohesive C value is good, so it is very good. That is good only at that time we checked it. We examined it, investigated it, but after that it will remain same. 20 years same, I cannot say. No one can say that. We constructed one tank, LNG tank foundation, the tank itself. I did not involve in that, but I was involved in records of survey formation. So we used to every week, I think we used to take levels of how much salmon is happening. So there were always variations in those levels, and we used to record every week what salmon is, how much. So it's very minimal. But as weight was going to increasing, raft to walls, and also cupola, and then further work inside, then they have to fill gas in that one time. So you know how much weight from zero at time of start of octo, it's going on thousands of tons one time. So certainly that will from time to time in that 1 year or 2 year time, this weight of soil will increase. Even though it is engineered soil, weight shall increase on that, and that will certainly affect level of that fill. If you have proved this that falling is 98% or 100% field density, proctor density, but because it is granular material, chances are very little, because there is no meaning of consolidation in that, because it never consolidates. If it is stationary, it is stable. Cohesive material is a problem, because this is compressible. Its pores can be reduced. That's problem. Pores in cohesive, in granular soil cannot be reduced until these are crushed. Because even if there is water penetrates in, water moves in granular soil, but water cannot move in cohesive soil. Though water remains there in porous capacity, it harms structure of soil if more water comes in, and that can or it swells out. I mean to say, when it dries out, it can reduce into that previous one or down further. That causes problem. So there we have to work on coefficient of permeability. But in case of granular soil, there is no coefficient of permeability, and there is no major consolidation, where it's engineered fill. And that's why we recommend always, if you doubt your soil, if you doubt structure of soil wherever it is, if you doubt that water may come in, water won't come as a stream, but it will come in some quantity. So that water should not. It should freely either move through foundation than go somewhere else. If your foundation whatever you provide is soil improvement by granular mix, that's a strong one, and water can pass through this gradually. Not with you can say turbulent speed, but just like laminar speed. It can move down and go somewhere else. Somewhere else it goes, so it can't stay there. It may take some months, it cannot sit tomorrow, it will do it. It depends, means what percentage of water is there, how much capillary action is there from below, so what has come up, or it's not coming up at all. If it does not come out, it's fine, it's good one. It comes, means if it's movable, so it will settle in your voids first, and then there is enough quantity to go away. So it takes time, and that is also a dangerous one, because if your soil is filled there in voids, it solidifies, sets in. So that also causes some problem, but that's not in our hands. We depend upon the capacity of soil, capacity of compaction, and how it performs, how it does. It depends upon them. Just give me 2 minutes, I'll be back. Because I have to go there. Come back. Sorry for that. I'll be back. Come back to again and see what to do. Engineering of soil. Now we're discussing engineering soil mobility is very important. In fact, I was talking about soil mobility as very extensive subject. In fact, we cannot simply take it for granted, and it's a very big part of soil. You can say I talked it before as well, but that was from and that was talked from investigation from Doha, and that was from some report. But soil movement, soil water movement, and mix of both or water presence is very big issue, because water and soil both are enemies together. Enemies together. In fact, both are different worlds. If soil is moist or soil is wet, means you have to be very careful, because You always used to draw water from well, and water from well means what? There is water table. There is a reservoir of water in the soil, so you don't forget that water remains separated from soil, and soil remains separate from water. So reservoir means is we can use water because soil doesn't come in that. It doesn't come from that because it's sand, it settles down, it's not clay. If there is clay, you can't drink that water. So remember, where there is well is useful only in sand strata. You can't use well from clay strata because clay cannot remain settled. It shall remain suspended if you just take out a bucket of water from that. It will disturb the soil particles will come up and stay there. And so water becomes turbid or becomes so silty or clay, and you can't drink that. So you are lucky if your sand area is like desert area. So water generally comes from sand area where there is sand, there is reservoir, and water is there. Now where you can dig out wells. When I studied this in my polytechnic, the first time they used to call it mota layer, M-O-T-A, mota layer. Mota layer is first water table. They should never take water from first water table because we used to learn that time how to dig well, how to use standing, how to use that curve, there's no curve when you dig a well. It's all curve, K-E-R-V, curve, not that road curve, but some curve, which was used as standing for purpose of digging well. And this used to just like we cut like a big cutter. It was not pipe cutter, but very big cutter, diameter, what's the diameter, 4 meter, 5 to 6 meter well. So you used to cut out that, take out soil. Excavation process was that. Go down X, Y, then put something, walls on that, something, so also go down, cut it. So it kind of, you can say diaphragm, raw diaphragm construction. We call it now diaphragm wall, it's RCC wall. That was another kind of diaphragm, very, very ordinary diaphragm. You have to dig well, excavation of well, and then you take out soil and go down and down, dig out like this, and put some windows, go down like this. It was, So there you have to reach a layer. Is never take out water from first layer, this called MOT layer, mota layer, because you can't depend on that water. Their second reason is because all sewer lines are there. All lines are there and water can go out into that layer. So it's septic water. So if you go to, if you want to take water from well or tube, you go to other layer, second layer, where water can be little better than first layer. That's true also because you go more and more below. So there's a stagnation and nothing disturbs that. So water is in a form free from mix of soil. That's natural. But now that time has gone. That was in those days when we were young, 74, 50s, 60s. We used to gather right. So here question is mobility of this, and mobility means soil should mix with water. Only then it can be called soil water mobility. Otherwise we cannot call it mobility. And that's where importance lies. I just went through some important files of that, and it's also a big calculative field. Means there is water out, and it's not immediately out. It takes time. You cannot say today, 1 hour it will come out. No, not that. It's out because it's a laminar flow. It's not turbulent flow. It's impossible to become turbulent flow because this is soil everywhere in ground. And there is no free area that water and soil can move in turbulent form, like water flows at weir or it flows at barrage. It's not possible that it should move there. That is beauty of that. We have to understand this difference. It's very, very important. So generally, we can say that is in laminar, we can say laminar flow, or you can say the Reynolds number is up to 2,500 or 2,000. I read same report. Same report I read, I think, from some official journal or paper also. When I was studying about microsilica long back, I studied also about this soil water mobility. But I could not clearly understand that time. But Now, because of experience and because a broader analytical mind, I can understand how it works. Because sometimes vision is important. How can you think of what you're talking? Something's written in a book, something is seen, but you can't understand until you do that. That's practical part of civil engineering. We cannot say, oh, I'm standing here, I'm working on this building. If somebody says, oh, see, you can destroy that building. Can you believe it? I am say working in my building as engineer. There's another building at 50 meters from here, or 20 meters from here, or 50, or say more from here. And some says, see, you are excavating here, you are working here, you may disturb that building. Can you believe it? You can't believe it. But it is. It's a fact. Yes, if it's rock, no, it's not a fact. Or if it is sand, maybe it's not that fact, but it is different one. Let us say it's different one, you may say it's different one, then it can be factual. It can be, we cannot deny this fact. This I was told this by one Iraqi engineer, very experienced engineer. That time I was not experienced, and we were constructing, we are excavating some underground pump station in Baghdad. So he questioned me this, did you take into your consideration while thinking to excavate this, or why doing this, that you are going to harm that building? How is that? This building is far, we are working here, how can you harm it? No. He also could not explain to me very frankly. He only asked questions. He was very senior, and he knew very good English. This means we are educated from somewhere outside, maybe in England or America, and he could not explain what he was talking, what it is this person. He said, based on my experience, I can say yes, you can impact that building. He was right. He could not say because there was clay area actually. That area was clay dominated in higher. If you just excavate up to 5-10 meters, 15 meters, we go down. Area was like that. Maybe below that there is sand. I don't know what was that. Just like in my area also there is clay immediately if you excavate. And if you go to 8 meters down, you will find sandy strata. So nobody will go 8 meters down for excavation for ordinary building. Who will go down? He said, no, why you excavate this? This nonsense, I didn't, though I constructed basement, I didn't go to that level also. There's no meaning, this is nonsense. Means you have to excavate and then disturb other buildings, because you, by more excavation, you are stressing other buildings also, because you are destabilizing other buildings, and this is a fact. We realize when we do what we don't realize. When explanation at raw stage or very original stage, until you understand theory. And if you understand theory, others will not understand that. You may understand, you may speak something, others won't, because they don't want to understand, and they say, he's not talking something logical, he's talking illogical. You may say that only. So that's what I also thought that time, what he's saying. I don't understand what he means, but that's fact one. When I got through other catalogs or biodata or theory, and still I am working on that now. I have gone through my career, and what I say, engineering never ends. At every step starts. So that's what I can say with guarantee today. Engineering does not end any time. In fact, it starts every time. Even after 20 years experience, 40 years experience, you start it. You say, yes, you have experience, you have known everything, but you can't say you stopped it. You start again. You start again. That's important point. That's important point. That important point, important point, and thanks. Okay. What is capital? Somebody said, hey, I like what to do. Are we? Oh no. No, I say, people will write something sometimes, and if I don't reply, they mind it. So I was talking about that, means when you start something, there is something, means if I start something, I think again. I don't think I know that. I think I want to know that. When I see some new drawing, I want to understand that. Though it's not, you cannot say I do not know that, but I want to understand more on that. And that more on that is very important. More on that is more on that, and people are writing something. I don't know what they want to say. So what I say, engineering is engineering at every new point. It's always a new start, and every person has a new start, and every design is a new start. Every contemplation is a new start. It's never say that I have done it, and when you've done it, means you learn from it. That's what I say. When I do something even small or big, I learn from it. That's more important. And because it's multinational activities, it's not single country activity. Everywhere there's a new thought. Everywhere new thought, like I never knew that hoodie slab is there, but it was the maybe you don't know what's actually you are even called in Arabic word hoodie slab, and it's of course very strong one. You can't say that it's very fast in case you can sell shutters of beams, and a shuttering of slab is very fast. It's a different kind of system, though it's not that easy, but it's workable, and it's fast, and it's of course lightweight. It works well in ordinary buildings like villas. I can't say about multi-story, but in villas it works, and like nowadays precast slabs, which we call hollow core slabs, for fast taking construction, that works too, and that means when we go to some new project. I'm not talking of technology. Technology is something else. I'm not talking of technologies. So when I start something new, I'm different means I am a student in that case. I act like a student because I have to learn something from that new environment. It's new for me because if something is new means new. What's wrong with that? But one day it will be old for me. So every project is new, every site is new, every site report is new. Of course, you can say reinforcement is not new, design is not new, but site is new, the specification can be new, or you can say procedure may be new. You may see you are in different world sometimes, different environment, or you have to, you have to, what I mean, you have to, what can I say, readjust yourself to that one. There is a system, you have to move it back. And there is no system, and sometimes there is same thing you have to do again and again and again and again. And for years together you do that. And you don't feel monotonous thing, you feel monotonous. But despite feeling monotonous, you have no choice. You are bound because you are in job. You can't give a job for your own sake. You have to survive. So there is survival question. And when there is no survival question, there is advancement question. Sometimes changing job is risky from employment point of view, but it's not risky from learning point of view. If you are opportune enough to get job again and again, this means you are better than those who stay in one job. They may call themselves that. Company may think this is our stable employee, and employer will think it's my stable company because there's a relation between employment and service. Means you are employed by someone, and you're serving that someone. So there's this relation between employer and servant, employer and employee. That relation, employee wants to see that, okay, I'm getting here, I'm okay, fine, I can pass all my life here. And that person says, this is my asset, I can use this asset forever. So there's a different kind of approach. Means learning is limited there. Means you have to stay in that environment forever due to stability of your family, due to stability of your career. But career is one part, while learning is another part. I'm not saying career should not be built. It should be built, but it should not be static. What I say, it should not be stagnant. Stagnation is not welcome. Stagnation means you start getting offensive smells, or there is no oxidation there, or you can say there is sedimentation. There is no sedimentation there. Always black water there. Means there are so many merits and demerits in that. You are sure of your future. You are contented with what you get there. That's fine. But is that true? What actually you want? Means I have no answer to that. I'm not criticizing something or not supporting something because I'm talking engineering. When I'm talking engineering, I'm not talking job. I'm not talking environment. That's another part of life. But when I'm talking about engineering, I'm talking about thinking. If everybody thinks of job only, or you can say stability only, then there can be no progress. And that's the reason that we are behind in this country. This is one reason. If you take example of this universe, I'm not talking about countries, our universe in which everybody is living, we are living, all other countries are living. Who built that? Can you ever think? Is not my duty as an engineer to think about that? Do I have no right? I have every right. Because I am an engineer. You think I am an engineer only for this earth? If I am an engineer, there may be some support from God. That's why I am an engineer. Of course, education is there, but I cannot eat that education until that power allows me to eat it. Eating means taking in soul. Eating means taking it in my soul, not in body. This education is not in my body. This is in my soul. My soul has been empowered by that education, by that power, universe power, that's called God or superpower, whatever you call, that power has given me this power of mind to know it. So does that power expect me to do something? Or just to live? That's it. That's what you have to decide. That power won't force you. But that power is super engineer on me. If I am engineer, that power can make me engineer. So what level of engineer is that power? And it's not engineer alone. It's all I'm saying, all education, whatever education is there. When you say education or siksha, it means something. Siksha, you see, this is a Hindi word or Sanskrit word, you may say siksha, is chai, shadow. Shadow, that shadow which is giving you a cover. Who's this? Sonu Yanaka. Talk about what she says. Okay, let me talk to you, Sonu Yanaka. What she says. Don't know what she says. Please allow Sonu Yanaka. Yes, hello? Hello? I'm not getting you. Hello? Sometimes I'll be upset with these people, calling for nothing, showing face only, or get lost people. Such people are there. I was talking about God and these people came in. God does not talk to no. God says you talk like that. That body will go to hell. So, when God gave me that energy, God permits me to work in engineering. This means God made me for that. Of course, that certificate is a medium only. Maybe God taught me that in that university, Vishwakarma University, I should say. There's no name Vishwakarma, so I'm called it Vishwakarma. It's no man, it's no woman. It's a verb. Vishwakarma, adjective. Vishwakarma, if you take that, I'm not talking Vedism, I'm just trying to understand analytical meaning of that. Vishwa is called universe, means not this world. Vishwa means universe, whole universe, Brahman. That's called Vishwakarma. Karma is worker, karmic. So that power which made this world through power of Brahman, Brahman in charges, whomever you can call that, I'm not naming that. Whoever is in charge and whoever this Vishwakarma is an engineer, we call him engineer. So there was an engineer appointed by that triangular power. That engineer came into me, came into you, came into every engineer, and we all working by that power. So if that power is there, it's not religion. Please believe me, I'm not talking religion. Don't take it otherwise. I am talking technique. I'm talking organization, which we presume it is that. It can be in different name, but we are taking name which we know. You can take some other. You can soul engineer. You can take any name. Universe maker. You can take any name. It's up to you. It's a reference only. It's nothing to do something. Don't take it otherwise. I'm not a religious person. I'm a soul religion person. I'm a human religion person. I'm a professional person. That's what I'm saying. I'm not nothing to do with any practical religion. Which religion never comes from there. Only our man-made named religion. These religions never came from sky. When I came to this earth, I did not bring any religious certificate with me. I came without religion. Whatever was given to me, I accepted that. That's no other difference. So when that engineer gave me this power, okay, you are my representative on this planet. You have to work for me. And he made not only me, thousands and millions like me all over the world. And we are working there. So when I work, it's not because I had to think of books only. This is biggest book. You have to understand what is engineering, and that is what engineering says. You have to understand your engineering power. You have to understand your insight. And if you understand that, you have to bring out something. Something is being cooked here by someone. It's you maybe, or it's someone else, your soul, or maybe your friend, or some power maybe surrounding you. That is giving some gift. And sometimes you get this gift, I solved it. Oh, yes, sometimes it happens to solve something you don't know, solve it. Oh, I solved it, I didn't know. I solved it with me. Then you write somewhere. You solved it. You are surprised. How it is. It's miraculous, unexpected. We call it unexpected or miraculous. But you don't remember that time. It's not yours. Because that power wants you to do something and you do that. That's why power said, okay, this is not able to reach this point, so I just tick here, so this point is for me. So I say, I got it. Though it becomes mine at that time, but still it's not mine. I say it's mine. Okay, fine. I'm not going to pay anything to that power, and that power is not sending me a bill. You pay me this. This is what is engineering. Engineering is nothing but mind. When I define engineering in 2 words or in 200 words, it can be defined. In 2 words, I can say think and do, and that's it. You understand? Think and do, that's done. Finish. And there is 2,000 what you can define, 20,000, everything you can define. Various stages, various processes are there, and just come in an organized way. You do something, and at end comes deliver. Think, deliver. Think, deliver. So simple it is. So this is a code in that case. This is a code of engineering. Think and do. Think, do, or deliver. Think, deliver, think, deliver, think, deliver. This is engineering. When you have to learn counting, you have to learn every part of counting. 1, 2, 3, 4. You cannot say 1 and 5 and 10 finished. No, you cannot say that. When you count your table, 3, 6, 9, you do all that. But you say no, 3, 10, 3, 60, 3 and 15 and 20 is okay. No, you cannot say 20, 30, not at all. You have to go in sequence of that. That is engineering. And you know that. Here is everything that when I say, oh no, I am student today. Sometimes I feel, oh, I don't know anything. I don't know why. It feels, everybody feels. Until you don't feel that, you learn, cannot learn. When you feel this, I know nothing. That day you are best student of engineering. And when you think, I can know that, I can do this, you can't be able to, you can't do that. Simple. Because pride stops engineering, remember. When they are in pride, it's a kind of challenge. In engineering, it's a kind of challenge. I'll do it. So you say, I'll do it. Yes, you can say. Why do you say, my point of view is this, why don't you do it? Let it say itself. You try to understand difference. Yes, somebody expects you to do that, fine, but never say with confirmation, I will do it. When you say you do it, I will do it, believe me, I assure you, at that day you will not be able to do it. I can assure you with full faith and full belief. Belief is not part of engineering, but as a person I am telling you now, not as an engineer, you won't be able to do it. But if you keep silent and say, okay, I think, I try. There's a difference of statement form. Okay, I see low profile. Because you are not going to do that. Somebody else will do that. So, why do you claim before doing it? So you do it. Once what happens, sometimes, explosion. What is explosion? There are 2 kinds of explosion. One explosion is physical explosion, where bomb explodes or something else happens and gas cylinder explodes. And there's another explosion where nothing explodes but everything explodes. Do you know what I mean? There's a physical explosion when bomb explodes or something else happens, or you use explosive device to explode rocks or blast rocks. That is one kind of explosion, and there's another explosion that is where you are explosion. You are exploding, you are bomb there. Then you ask, why am bomb? You are different kind of bomb. You are not that dynamite bomb or RX, RDX. You are bomb in different way. You are a bomb in a way that, so say you are working in an office, big company, and there's so many people. You are not same, you are not maybe you think you are different, or they think you are different. You are not boosting, you don't boost anything. You just start your work as usual, and they don't take you in high profile because you have just normally started, even though you are very big there in comparison to others, and you are maybe head of that, but they will try to watch you, what's your character, what's your style of working, what's your mental capacity. No, they cannot come immediately and ask you that until you are in their office or you sit with them, that they can interact with you. They may say, good morning, sir, this and that, not more than that, or they come to you with some sort of, but they have no power to ask you because you are very gentle, you are very so low profile, and sit there, assign them work and talk to them in very pointed way, not in a way of chatting with them and in beginning and mixing up with them with laughing and shake hand. So a kind of reservation lies with you, and that reservation stops them to come to you open-handedly. And what happens? If maybe you are equivalent to them also sometimes. So when you come in time, you go in time, or you stay there more than that, more than required, and you just work and you continue with your work, you progressively you do, and they realize that you don't depend upon those people because you yourself extract information, you don't ask them. So there's a big problem in that. Because they expected you to depend on them. Everybody expects, oh, this person is new, this person shall come to us automatically. So this person has to ask us for some information. But they little point could not understand that information is not owned by you. Information is available somewhere, and nobody will ask you personal information. If somebody asks you some files, and if I'm quite strong, I try myself. Sure, give me these files, that much can ask you. So you can't say no, you have to give all files. But this is now computer world, server world, where everything is online. So even that situation is off. But even then, they expect that you are new and you do not know about this project. So you have to certainly ask us. And if you ask them, fine, they feel happy. Okay, he's asking us. But that too, in message, they want to know more. They want to know more about you. And they will say backbiting, say this person is very pride, and this person thinks of what does it think of it, ask someone and he moves himself out. But you do not respond to that. Okay, this is until you mix up with them, this kind of environment works because you didn't mix up them. So that's what they expect, you'll mix with them, but you did not do that. So you can say, but the time comes when think that this person is very punctual, this person comes before time or doesn't care for time, and this person gives instructions to everyone what to do, what's your job description, what's your scope of work. So this person commands everybody. So that person is very dangerous for them because they wanted something you did not give them. They wanted something you kept silent, but you are very successful. So this means you are very dangerous for them. And if you are maybe in their capacity, then they may say sometimes to you, you are doing overwork, you are coming early, why are you coming early? You are going too late, why are you going too late? Like that situation. So what I mean to say is that is very explosive situation where souls of people are affected, not bodies, souls. Because they start thinking that their survival is challenged. If you mix up with them and you talk to them, they okay, this is our friendly person. But here work is going to speak to them, not you. And that's where dangerous lies. Danger lies there. If your work speaks, you don't speak. Where you speak, work doesn't speak. Their common life exists. Common life, everybody. Because those people who speak a lot, it's well known and established that they do not do anything. And who take too much, then they don't do anything. They never do anything. Or they destroy whatever is existing. Those who talk too much, oh, I will do that and I will do that and I will do that, and you see the whole system collapses. That is what world is. And that is what our engineering is. I can do this and I can do this. You talk whole day like this. But when somebody asks you, have you done? Oh, I'll do this tomorrow. I'll do this today. Give me some time. Give me. In that also will talk. He won't start doing that. Reason is that person does not know job. Point is that. If you know job sincerely, why shall you speak? Your job shall speak. But here, even when you ask who is you either know this was a problem and that was a problem and that person didn't go, that person didn't give a report and I asked that person to be this. You will give 10 excuses, but you will not go to any person to demand anything because you do not know what is required. If somebody asks you, make what you want, you will not give any what I want that, I want that. You will not give any concrete answer. And that person who asking you what you want, that okay, go to hell. I don't. You are that kind of person who only shouts, only can say something, never do. Or if you do something and you do not know what you did that, you just do it. Or you took from this information here, you take this information and you compile some, go say I have done this. So you can't explain that also. Because to whom you are giving, he certainly shall go through your paper, why you will do this, why you did this. Okay, I shall tell tomorrow. You shall tell tomorrow. Why don't you tell now? This means you will ask someone and respond to me. There were such people I have seen in my life. I have seen such people who used to claim that they are engineers. And they were engineers from very high profile universities like Aligarh Muslim University, high profile university. And like, such universities where you can't say no, such universities. So, I am from Aligarh Muslim. Okay, fine. Means he keeps you so busy. He keeps you asking this and that. Means irrelevant questions so that you never ask him anything. And you just use him or you use him. Means he keeps him. But when you ask something, what is that? Oh, this happens like this. He will divert your attention, no problem. But certainly, he is so sincere, He is so sincere. He shows that he is so sincere. Within next day or 2 days, he will come to, oh, so you asked me that, I remember. Oh, that's how it is done. Yes, he knows. He did not tell me yesterday. Today he is telling. So I still doubt. How he knows? Maybe I think he read book or something. But no, it's not that. There are some people in engineering which are very smart, over smart. Actually, they want to survive and they are not engineers in fact. They are fake, but they want to survive. So you should have sympathy for them, not apathy, because they have family, they want to survive and you have to stay with them. They are so powerful. They are powerful in such a way that a person who appointed you, they have access to that person in a more complex way than you have. That person who appointed you is more related, closest to them. So it's not easy for you to handle that person in negative way. So in that case you handle that in positive way. Accept that person, that's it. What can you do? Everyone you cannot fight with. This is after all world of engineering area. So what happens then? You have to teach that person. That's another way. Because engineering degree is not required every time. If there is some work like measurement, everybody can measure. Levels, everybody can understand level. Drawings, one drawing you try to understand, second you can understand yourself because drawings are all typical. And say in certain big plants there are no so complexity of drawings like a building has. If you have a building design, building is very much complicated. The cost is not that high, but it's very complicated. So it's not easy to understand theory of buildings or coordination of buildings. But sometimes you have no. So I have seen such engineers also. That's why I cannot say, I cannot generalize to what engineers are. How can you say this person knows job until you experience that person? You cannot say your dressing sense or your talking. Some people know very good English, but they are nailing job. So what you say? Yes, you are good English because you are qualified from English medium. It is a college, a school for your education. and then you that base has not eroded. You talk in your family, or you talk somewhere, or you see such films which are English. So you improve your English knowledge. So improvement of English knowledge doesn't mean you improve differential calculus, or you improve integral calculus, or you know modern physics more than what I know. If you want to know that, you have to sit down and concentrate, because those subjects are very boring and very complex subjects. English is a language only. So by English impression, you cannot say that you're intelligent. But it works, means somewhere it works, somewhere it doesn't work. Where your knowledge what shall be required of engineering, there you fail them. You should come out there. You can't exist there. That's why I say everything is new for me. Every experience is new for me. Every colleague is new for me. When you meet once with somebody, you feel, okay, fine, I'm glad, you are glad meeting each other. That's just formality. Nobody is glad, in fact. Nobody is, and I'm pleased to see you. No one is pleased to see anybody. It's just a formality. If you don't do that, this person is having pride, or this person doesn't have manners. You say like that. So just to show that one is manner, one is a manner, much pride means you say, okay, fine, we don't want to, maybe I don't like your face, say something happens, but I will shake your hand. So this is what where life is, when practical plus theoretical plus intellectualism all have to mix together. Only then you can move. You can say, because I don't want this man, you have to use that man. If you are forced to use that man, what you do? You don't like someone, but you are forced to do that. So there's no way out. You have to use that. That person is powerful. So this happens everywhere. In government it happens, in private sector happens. That you have to depend on yourself. Sometimes you have to work, others works also, because those people don't work, and you are so powerful, you can't remove them. So that's why I say every experience is there. That's why I'm talking about soil, water, mobility. Soil, water, mobility is something like that. You don't want that, this doesn't want, but force it, or you have to be forced either of that. These both points are applicable here, and these are very important points. Usually I say that sometimes particularly in office engineering, where you have to coordinate yourself, is better. You can do faster than giving job to someone else, your subordinate. But on sites, this is not practically possible, because it's physical work, and you have to instruct them, and instruct to right people only. You cannot instruct everybody also. Even if they are well placed and well minded, and they don't do job, then what's meaning to instruct them? But you can't remove them, or if you have a chance, or you teach them, and they teach them only if they are willing. If they are not willing, you cannot teach them also. So there are people of all sorts, all classes everywhere. There are some people who want to learn, who are hungry for learning, and there are some people who don't care for learning, because they don't value you, they want something else, and you cannot push them off. So this is for all. That's why I'm saying every information that I get in engineering, I know it before, fine, I don't care, but when I don't know that, I try to sit down and try to find every time what I did. So engineering is different world, I should say. It's not same world as you think, and we should not think it is same world. It's world of it's world of complete change, complete new vistas. We have to find new vistas. We have to find our old vistas cannot work, and we have to change ourselves. And in fact, if possible, we should not stick to one place. If possible, I say, not necessary that it should be, if possible. I should say that it's possible, and it should be that. So I can say that engineering is that. You cannot say no, it's that, and that's engineering, and that's world of engineering. And well, I was talking somewhere and I have drifted to this. Really sorry for that, but this is explanatory words. If you have to explain, you cannot stick to one point. You have to, just like moment distribution in frames, as I usually say. What's moment distribution? We do in one way. We say, okay, we can on one portal frame this moment distribution. If it's in Canis Chinese rotation pendulum is much more advanced, I think. It's much more reliable also. I like that one cycle, two cycle, three cycle, and half goes there, and half goes here, and half goes further there, and half goes further there, and this is here, and this is beautifully designed by German engineer. Yes, though it's not very complicated, it's good one, but it's quite dangerous. If you expand this, you will get real answer, perfect answer. You can get, and that is reliable method. And our teacher used to say in that I was learning that do not abuse this theory, this theorem, Khan's conclusion method. This is only for high multi-story and complicated, and not for very, you can just use for anything. So I am like that, when you enter into some complex world of engineering, then you automatically raise your level of understanding, raise your level what you have to do. And that's not because of you want that, it's automatically then if you expose yourself to understanding, to new subjects and new technology, you think on that, because you can't understand if yes, you attend class, maybe you don't have opportunity to raise questions, and then you can raise somewhere else, or you can go to that class and there's a place I need some hour, you explain to me separately. So that's another point of view. So one can do that. It means it's not possible. But I mean to say that what I understand about this, that it's very wide world of engineering. I mean to say civil engineering is something you can say it's miraculous, miraculous sometimes. You can do many changes if you want. You can have options, many options if you want. Same building can be designed in different ways, same structure can be designed in different ways. There is no hard and fast, you have to do this. As far as you apply procedures, you apply principles applicable or codes applicable, as well as applied, plus charter of basic and charter of working, basic management and working management. Same, there's no problem at all. It has to be done, it is done, and I think that what they want to say, I don't know. Therefore, I would say to my colleagues, to my friends in engineering, that better use time. Yes, you have family, you have jobs, still you have time. Use that time for engineering better. Quality is again same point I come. I like quality work. Even though it's temporary work, I like quality work. I can't digest non-quality work. If it is permanent work or permanent inclusion, because it's not because it's my wish. It's not because my wish. It's because whatever we use on projects, on structures, we use naturally produced materials. We do not make materials except some cement which is manufactured one, or you can say steel bars which are manufactured one. Generally, these are basics of society these days, that you have to use this material, that material. But if other party also comes, they should like today in that way. But I do not believe in wasting natural properties, natural materials. We have to optimize its use. Quality is ultimate destination. Ultimate destination in a sense, it has to work positively. No cheating. Even if you cheat, whom you are cheating for, you have to understand that. You are not cheating, you are cheating yourself. You are not cheating anybody else, you are cheating yourself. Because it's your job to give quality, and because somebody is stopping you from that, or somebody is not happy with you, it's not because of that person doesn't know you, because you don't know what you have to do. Quality is a target, it's a challenge in fact. I consider quality a challenge. It's not because I am saying, it's fact. It's a challenge. You will say, how is it a challenge? If you are doing quality work, that you are saying. You are saying. Okay, you go and review your work again and tell me this, do the same thing. Because you have to say I am doing quality work. That's because you are working for that work and you are getting payment. If you compare some quality activity, you check your own work, you will find differences. What you did before and what you think now, oh, I should have done this way, but nothing you can do that. So, my talk is mainly for quality. I'm not talking about procedures, but for getting quality. To achieve quality, you have to devise procedures, and those quality is dominated by this procedure, but this procedure should also be quality management, quality organization. And that's where quality organization or safety training lies. Safety training cannot mandate you about procedures or about specifications, but you know that after 9 months, 3 months or 9 months, or still I don't know what this is. So my dear friends, quality is not well defined. It has on you means what is expected, that is minimum, and what can you do is maximum. So quality criteria, and particularly concrete quality criteria, in fact I am not talking of general quality criteria, because if concrete is good, you can do quality work in others. And if concrete is not good, when I say good means quality concrete, because material already you are implying. How to, first of all, material should also be quality. That is not quality one. So what do I mean? I mean say that your project is your responsibility, your life is your responsibility, and your country is your responsibility. No other responsibilities. It's up to you. So gentlemen, if you go on ahead, I talked yesterday about, I think, about concrete. I was going through concrete, and I talked up to, I think, hardened concrete, inspection of hardened concrete. Hardened means the concrete that has set, that has started gaining strength. That's what hardened concrete. Let me go back to that one if I can find that. I talked of that before, because enough is spoken. Now let's see what this quality document says. Because I think in this hello format, that file is still not there. I see, no problem. Alright, so this is document concrete and we were somewhere, I don't know which page it was. No, not done behind. Not done behind. Form work. Was that form work? No, I don't want to do form work. Transportation placing I have done. Form work, I am not interested in form work. Curing, I think I repeat it right. So I repeat curing better. It was done that way, but let us repeat the curing. How many pages are there that I see? I believe I think not many. So let us do it for sake of ourselves. Here's section 5 and it says, this is 10 in this, section 5 says curing. What's curing? I'll see that one. Let them behind what to say. So it says first is this scope references, and let us see what mine is. Scope references, submittals, quality assurance, storage, curing is general, water for curing, general requirements, curing of formed surfaces, curing of unformed surfaces, moisture curing, moisture retaining, cover curing, liquid membrane curing, steam curing, pavements and other slab on ground, buildings, bridges and other structures, and mass concrete. I'll move fast because I've already done, just repeat is there and see. In this covers following parts and water property requirements. So well, I'm not concerned. I like scope. Now I'm directly into this. Contractor shall submit to engineer for your proposed methods for curing for approval, and it's important there that you have to put that one. This contract is submit to engineer proposed method of curing for approval, and quality assurance means contractor shall submit to engineer for approval details of proposed curing media. If any details shall include chemical tests for product in accordance with PSN 542 and details of quality assurance procedures including this and that. So storage is chemical curing compounds shall be stored in accordance with manufacturer's recommendations. So curing storage is thus chemical curing compounds shall be stored in accordance with manufacturer's recommendations, and curing is general is what this is. Contract shall ensure the curing is provided for 24 hours per day, including holidays, and that all related necessary plant and labor or workers resources are also available. So contractor shall ensure that curing is provided for 24 hours per day, including holidays, and that all related necessary plants and labor resources are also available. Special attention shall be given to curing of vertical and overhanging surfaces to ensure satisfactory curing. And that contractor shall adopt Curing, context a lot of curing measures that preclude the context a lot of curing measures that preclude possibility of thermal shock, possibility of thermal shock to countries shall adopt curing measures that preclude possibility of thermal shock. Thermal shock is very important here. This is another term I studied before as well, thermal shock to concrete during curing. This may be achieved by ensuring that temperature of water used for curing does not differ from that of concrete by more than 15 degrees Celsius. Curing shall continue for at least 7 days and until it attains an in-place compressive strength of concrete of at least 70% of specified compressive or flexural strength, whichever period is longer. Curing shall not stop unless otherwise approved by engineer. When low water cement is used, concrete shall be preferably cured by water. Water for curing. Water used for curing purposes shall conform to requirements of Part 4. General requirements. Freshly placed concrete shall be protected from sun, wind, rain, exposure and excessive drying out. All concrete shall be cured for a period of time. All concrete shall be cured for a period of time. All concrete shall be cured for a period of time required to obtain full specified strength. All concrete shall be cured for a period of time required to obtain full specified strength, but not less than 7 consecutive days. Method of curing shall be by water. Shall be by water for first 7 days and by water or membrane until concrete has reached full specified strength. Method of curing shall be by water for first 7 days and by water or membrane until concrete has reached full specified strength. For mixture with low to zero bleeding rate, or in case of aggressively evaporative environments or both, curing shall start as early as time between placement and final finishing of concrete. Curing shall be by reducing moisture loss from surface using fogging systems and use of evaporation reduces such as monomolecular water curing compound. Again, I say this that molecule is an important point for mixtures with a low to zero bleeding. Low to zero bleeding means bleeding is there, but low to zero bleeding rate, or in case of aggressively evaporative environment. Zero bleeding means there's evaporation, there's no water coming up. Or both. Curing shall start early as per any time between placement and final finishing of concrete. Curing shall be by reducing moisture loss. Curing shall be by reducing moisture loss from surface using fogging systems and use of evaporation reducers. So you can say curing shall be by reducing moisture loss from a surface using fogging systems and use of evaporation reducers such as monomolecular water curing compound. Exposed surface shall be protected from airborne contamination. So it says curing shall be by reducing moisture loss from surface using fogging systems and use of evaporation reducers such as monomolecular water curing compound. Exposed surfaces shall be protected from airborne contamination until 28 days after concrete is placed. Put this on. This one is same thing I can say. This one is same thing actually. Method of curing shall ensure that sufficient moisture is present to complete hydration of cement and shall be to approval of engineer. Method of curing shall not 1. Disfigure permanently exposed surfaces, affect bonding of subsequent coatings, increase temperature of concrete. There are 3 requirements, means this should not do that. Disfigure permanently exposed surfaces, affect bonding of subsequent coatings, increase temperature of concrete. During current curing period, exposed concrete surface shall be protected from direct rays of sun. So when you say curing period of exposed concrete surface shall be protected from direct rays of sun when liquid membrane is used. When liquid membrane is used to cure concrete, it shall not be applied if bleeding water is present on surface of concrete. Applied film of liquid membrane shall be continuous and protected from rain and any damages for at least 14 days. Feeling sometimes lazy, how to get out of that. After all, so when liquid membrane is used, say when liquid membrane is used to cure concrete, it shall not be applied if bleeding water is present on surface of concrete. Applied film of liquid membrane shall be continuous and protected from rain and damages for at least 14 days. Curing of on surfaces, this is also very important, but in general I have not seen people doing that. Really, it's specified now, but I have not seen people do that because of arrangements of doing that. It's not easy. Uh, form surfaces, including on the side beams, girders, supported slabs, and like by most by moist curing, by moist curing, with forms in place for full curing period, or until forms are removed. When forms are stripped, curing shall continue by whatever approved method. When the liquid membrane curing is used, it shall be applied immediately after the removal of shuttering, and such cases, concrete surface shall be prepared. In such cases, of concrete surface shall be prepared prior to application of membrane as recommended by manufacturer. Water curing is not required when liquid membrane is used. Curing of unformed surfaces. Let's move further. Sometimes, I don't know what happens to me. Well, switching, switching is problem. Unformed surfaces shall be protected as soon as possible after concrete has been placed by polythene sheeting. Generally it is, and I say many times on my postings, do it, but people do not do it. Unformed surfaces shall be protected as soon as possible after concrete has been placed by polythene sheeting. When sufficiently hard for this will not, I don't know that this will not actually this version. Alright, so I'm going there now. What's this? This page, this page is here. Yes, it's there. Yes, I just by mistake I clicked that. So we have to see, you have to spread polythene sheeting and one sufficiently hard Asian or other absorbent material shall be placed on concrete surface and shall be kept wet for required period. Patient shall be overlaid with sheet of 1000 gauge polythene. So now once concrete is sufficiently hard, top exposed surface of walls, columns and beams shall be water cured and and covered with wet Hessian for required curing period. Moisture curing. Put light on it. Light's not required. Moisture curing. Numbing. Moisture curing shall be performed by, how shall be performed? Moisture curing shall be performed by covering surface of concrete with water and keeping it continuously wet. Moisture curing shall be performed by covering surface of concrete with water and keeping it continuously wet. Continuous use of fine fog water spray, covering surface with a saturated absorptive cover and keeping it continuously wet. And burlap cotton mats and other absorbent materials can be used to hold water on horizontal or vertical surface. Wet straw or hay can be used for wet curing, but there is danger that wind may displace it unless it is held down with screen wire. Burlap means where method 1 is employed, you can say bunds shall not be made from fill from excavations or any other areas where there is a possibility of chloride contamination. Right? Where method is employed, so the bunds used shall not be made from floor, from excavations or any other area where there is possibility of chloride contamination. Moisture retaining cover curing. A concrete surface shall be covered with suitable absorptive covering such as wet Asian. Absorptive covering shall be overlaid with 1000 gauge polythene sheet. Cover shall be widest practical width. And shall have 100 mm side and end slab. Penetration of peels penetration of tears in covering shall be repaired with same material and waterproof tape. Liquid membrane curing. Liquid membrane oh, uh, liquid membrane curing. Liquid membrane curing shall be in accordance with requirements of BS 7542 ASTM C309 or C1315 when tested at rate of coverage used on job. Now, sorry. ASTM C156 shall be used as a test method to evaluate water retention capability of liquid membrane forming compounds. ASTM C1151 provides an alternative laboratory test for determining efficiency of liquid membrane forming compounds. Membrane forming curing compounds shall be applied in accordance with manufacturer's recommendations immediately after any water okay, so what do we say here? Says that ASTM shall be says that AMC 156 shall be used as test method to evaluate water retention capability of liquid membrane forming compounds. ASTM C1151 provides an alternative laboratory test for determining efficiency of liquid membrane forming compounds. So in this test provides an alternative laboratory test for determining efficiency of liquid membrane forming compounds. Membrane forming curing compounds shall be applied in accordance with manufacturer's recommendations or instructions and immediately after water sheen is made up after finishing has disappeared from surfaces and within 2 hours of stripping formwork surfaces. Membrane forming curing compound shall not be used on surfaces against which additional concrete or other material is to be bonded unless it is proven that curing compound will not prevent bond or positive measures are taken to remove it. Now it's proven that curing compound will not prevent bond. Positive measures are taken to remove it completely from those areas which are to receive bonded applications. on fast on fair brace. Alright, now we say steam curing. It's very important point, steam curing, though it's very small in one paragraph, but it's very important. We have to understand that point. Very important. It's very simple and very important. Both are the, you can say that. So it's that. Let me put it down, please. It's now recharge, so I put down my battery for half an hour. Let me try, maybe I miss it again. I can't say, let me try. Put down, then put down, see it goes little light, no problem, but you know, it's important also sometime. I put it down and let's see how it is. So an enclosure, remember, enclosure is point here. An enclosure to be formed, an enclosure is formed around concrete using tarpaulin or other suitable means. Application of steam shall not be commenced until at least 2 hours after final placement of. Steam shall be applied at a temperature below 65 degrees and 80 degrees. Between 65 degrees and 80 degrees Celsius. This is temperature is very important. Keep in mind, this is 65 degrees and 80 degrees Celsius, and you cannot enter there. Remember, in 65 degrees and 80 degrees, if you can't tolerate that, you can't enter in that, because it's 50-45 outside, you can't enter. So they are in tarpaulin, it's 65 to 80 degrees. Okay, then we say, this is 65, 80 is very important point here. We should keep this in mind, that steam area is not accessible to, in fact, only to maybe to some operator, because this is contained area, this is sealed area. Steam should not come out. So there is someone inside there's some machine inside captain, and this would get that. The steam shall be applied in temperature. This excessive rate of heating during application. So this is very important, but I just stop at this point. How to control that steam curing, because this is steam curing is very important for, and we call it autoclaving, this very important action, and this is particularly applied on precast members or pre-stress members as well as in many cases on concrete blocks. You have to supply blocks immediately, means there is no place to wait for blocks. But don't for this expensive items, and particularly for precast slabs, use them so we can ship those immediately within a couple of days to site. So steam curing, yeah, I don't know. I need to carry on with that. I'm very surprised really autoclaving. I studied autoclaving, but method of autoclaving I wanted to see. I'll find somewhere else, if not here, no worry. I'll find somewhere else. Now after this I'll try, it's very important. Excessive rates of heating and cooling shall be prevented. Excessive rate of heating and cooling shall be prevented during steam curing, and temperature in enclosure shall not be allowed to increase or decrease by more than 22 per hour, more than 22. Means you can add, say your temperature is say it is 65, and 65 can go only to 82, not more than that, or you can say up to 80. And if you go down by chance, it is 65 down to 22, less than that. So this is 43. So 43. So like that, we have to see what can we tolerate, what we cannot tolerate. That's the point here. Autoclaving, I'm going to find out. And it's very important for me that we find autoclaving somewhere. Go to that one, autoclaving procedures. Let's see. Autoclaving is very, very important point. Autoclaving. This person is how much? It's 1 hour 53 minutes. It's autoclaving. Autoclaving. So autoclaving. It's not an address. Auto. Zero. Autoclaving. So its autoclaving is often used to sterilize medical waste prior to disposal in standard municipal solid waste. This application has become more common in an alternative to incineration, and my point is not that. What is autoclaving? Autoclaving is process of sterilizing supplies and equipment with use of high pressure, that is 120 Celsius above 15 minutes. This process is widely used in all fields of medicine, industry, microbiology, veterinary sciences. Autoclaving, why not doing autoclaving here? Autoclaving pronunciation, translation, English dictionary. Autoclaving is stone pressurized, steam heated vessel as laboratory experiments. Autoclaving is method used for decontaminating cultures, glass vessel pipelines. Autoclaving is very, very dependable method for sterilization and glassware, medical waste temperature. Autoclave method, let us see, is not available right for it. So that's food. Autoclave is not that. Autoclaving is a bit like cooking, but it's as well as keeping an eye on temperature and time. Pressure matters too. Safety is all important since you are using high pressure, high temperature steam. You have to especially careful. Be careful when autoclave. But there's there's autoclave manufacturing, autoclaving manufacturing, find autoclaving procedure of autoclaving. Let's say something autoclaving, let's say autoclaving, let's say blocks, hollow blocks, let's say hollow blocks, hollow concrete blocks. Start with it. It's not giving. I don't know. I couldn't find it. Anyway, I couldn't find this. Leave it. I wasted my time. Couldn't find that. Well, no problem. So I will find somewhere else because this is very rare process. The general fact is only so autoclave was high. Well, temperature for 65 to 80. And 22 gap is important, so you have to keep in mind gap 22, that is temperature variation is 22, do not do more than that. So maximum steam temperature shall be maintained in enclosure until concrete has reached its specified strength. What I'm saying is temperature of autoclaving is between 65 and 80 degrees Celsius for purpose of curing. 65-80 degrees Celsius for purpose of curing. It may be concrete blocks, it may be concrete, hollow blocks, hollow concrete blocks, whatever, curing purpose. So it's also true that no one can go in 80 degrees and 65 degrees Celsius. You cannot. It's not easy to enter that without your specific dress. So if we are able to find that, maybe somewhere else in this specifications, investors are not trying to define, let's see how to define that. But if it's defined, I think that as you know, So we now move to X1, and that is pavements and other slab on ground. Autoclaving is still unclear, will take some other time. We'll find this procedure because I never did it, I was not employed in factory. I can't say how they do, but it's clear that there's a containment in which you keep materials. So this means there can be a yard, and all these because column members can be placed in the yard, and that can be contained by something, and that's not a problem. Means you just put steam release into that at certain temperature and come out of that because you are not necessarily there. So still can move throughout that portion. There's no leakage. And steam is killed out. You see it farther. So let's go to pavements and other slab on ground. So we'll go along. Says that pavement on the slab on ground, and that is curing shall ensure that no plastic shrinkage cracks occur. No plastic shrinkage cracks occur. This can be done by protective measures such as sun shields, wind breaks, evaporative operation reduces or fog spraying should be initiated immediately to reduce evaporation. Mats used for curing can either be placed and kept saturated for completion of curing, or can be subsequently replaced by mats used for curing can be left in place, kept saturated for completion of curing, or can be subsequently replaced by liquid membrane forming curing compound, plastic sheeting, reinforced paper, straw or water. Building, bridges and other structures. Additional curing shall be provided after removal of forms. After concrete has hardened and while forms are still in place on vertical and other form surfaces, form ties may be loosened when damage to concrete shall not occur. And now let's go to this one. This is after concrete has hardened and while forms are still in place on vertical and other form surfaces, form ties may be loosened when damage to concrete shall not occur, and when water applied to run down on inside the form to keep concrete wet. Care was taken to prevent them from thermal shocks, and care should be taken to prevent thermal shock and cracks when using water that's significantly cooler than Alright, so care should be taken to prevent thermal shock when you have to do that. So immediately following removal, surfaces shall be kept continuously wet by water. Spray of water saturated fabric onto membrane forming curing compound is applied. Mass concrete. It's not completely given here. Let's see what is given here. There's more than that also applied totally. It's mass concrete. Mass concrete is often cured with water. For additional curing of time, let me see, time is important here. This is 1 hour, 31 minutes, 82% remaining. Okay. So mass concrete is often curing with water. I don't know why it's for additional cooling benefit in warm weather. However, this can be counterproductive when temperature gradient between warmer interior and cooler surface generates stress in concrete. So mass concrete is often, so we have to see that so this can be, mass concrete is often cured with water for additional cooling benefit in warm weather. However, this can be counterproductive when temperature gradient between warmer interior and cooler surface generates stress in concrete. Horizontal or sloping unformed surfaces. Horizontal or sloping unformed surfaces. For vertical and other formed surfaces after concrete has hardened and forms are still in place, so formed ties may be loosened and water supplied to run down, water supplied to run down. This again stopped. So this problem here stops. It is 774. Stop again. So this care shall be taken to prevent thermal shock and cracks while using water that is significantly cooler than concrete surface. Curing water should not be more than about 11 degrees cooler than concrete. Here it is 11 they are cooler concrete. Care shall be taken to prevent thermal shock and cracks when using this and avoid of this. So care shall be taken to prevent thermal shock and cracks when using water that is significantly cooler than concrete surface. Curing water should not be more than about 11 degrees cooler than concrete. Okay, so it's 11 degrees difference. Curing shall start as soon as possible. Concrete is harder, sufficient to prevent surface damage. For unreinforced massive section not containing granulated blast furnace slag, And without GGS, I want to say, Barcelona curing shall continue for not less than 2 weeks. Background, the GGBS slag plasma is included, then it's for 3 weeks. And for reinforced mass concrete, curing shall be continuous for minimum 7 days until 70% of specified compressed stress is obtained. If strength is one, strength is criteria, concrete criteria. So that's another point we say if reinforced mass concrete shall be continuous for 7 days of until 70% of specified compressive strength is obtained. If strength is key concrete performance criteria for construction joints, curing shall be continuous until resumption of concrete placement or until required curing period is completed. Curing shall not stop until favorable differential temperature is attained, and at the same time so we'll go to next one. It's okay. When some are saying this is a concrete, for mass concrete, thermocouples shall be used to monitor temperature differential of concrete thermocouples, and this is also important. Let's see, this is an important point here. Thermocouples, and I think it should be important one. Okay, what's not important? Yeah. I think that's a problem. So thermocouples is also very important one. I'll try to find out that as that thermocouple in somewhere. Javi या तुम्हारी ऐसी या thermocouples, so thermocouples. Thermocouple is here, and this is thermocouple search itself. It's like thermocouple, thermoelectric device. I'm not talking thermocouple. I'm talking thermocouple is an electrical device consisting of two dissimilar electrical conductors forming an electrical junction. Thermocouple produces a temperature dependent voltage as a result of thermoelectric effect, and this voltage can be interpreted to measure temperature. Thermocouples are widely used type of thermal temperature sensors. Let's see this actually. Let's see what is that. Better if you see it now rather than forgetting it from thermocouple. Let's see what's that. This is the welcome to thermocouple info. Thermocouple is a sensor used to measure temperature. Thermocouples consist of two wire legs made from different metals. Two wire legs. Legs are welded. Wire legs are welded together at one end, creating a junction. Okay, so this is one part. So what I say is, I can't see your eyes. Again, my eyes. Says thermocouple is a sensor used to measure temperature. Thermocouple consists of, okay, this is okay, temperature you can sense. There's a many types of thermocouples, each with its own unique characteristics. And I want to see something here. These are not, yeah, there is one type thermocouple before discussion of type K thermocouple and type K are extensions. So these are thermocouples. And temperature range thermocouples, grade wire minus 453 to 2, so this minus 270 to 12 126, these extension wire 32 thermocouples. So we have to know temperature, that's why I'm looking after this thermocouple. Let's go, leave it and go somewhere else. Thermocouple, rising falling temperatures, or I should say rising falling. I think that will give a better idea. I'm changing such, it's a rising filing differential thermometers, rising falling differential thermometers, and this is thermometers using differential temperature. That's what's required actually. Thermometer using differential temperature measurements. Thermometers using differential temperature measurements utilize a pair of adjacent temperature sensors initially at different temperatures in order to measure temperature of a common surface over a pre-selected period of time. Thermometer includes a housing and first and second thermistors mounted adjacent one another on housing. Finest first and second thermistors are adapted for positioning against surfaces can be body part or oral lecture. Everything you need to know about digital, not digital is not difficult area. Digital thermometers, electronic thermometers. Leave it like I can't understand. It's there, means we use this, that's enough now what to do. We're finding the information. So we have gone with this now. And then this reinforcement will do later now. Now other part is that this I'll take later on this one now. Again I'll go to convert, so that's the front one. Reinforcement is not currently, I'm not going to do this, I'll discuss something else. I was looking for something really different here. Still I'm not able to see this because of this reflection coming from there. I try to see this side, but reflection is still there. And next one is moment joints or sector. What I say here is that well, I'm starting just a little more explanation I'm giving about, about what you say, curing, which I was talking about. Curing is curing a massive block. Actually, the specification also could not reflect that correctly. I was expecting massive block curing. There are three types of concrete materials, concrete elements we deal with. This is also a very important point. Three types of these, and they are, that one is ordinary member. Ordinary member, in a sense we say ordinary member, that is, you can say ordinary in a sense that for example a column is 30 cm by 30 centimeter, 30 by 50 centimeter, 40 by 40 centimeter, or say 3 meter height, or say any wall 15 centimeter wide or 3 meter height, or you may say any slab, you can say 15 cm thick, 20 cm thick, or you can say foundation that we do up to 40 centimeter, 50 centimeter, whatever dimension, 2 meter, 1 meter, doesn't matter. or you can say complete beam or raft all the way up 40, 30, 40 centimeter. All these what I'm saying is which are whose dimensions are less than you know less than 80 centimeter thick, less than 80 centimeter thick. Minimum dimension is less than 80 centimeter thick, 800 less than 80. That members are called normal members. Normal members means quantity may be whatever, it doesn't matter. But these are all maybe 500 cubic meter slab is there, but all members are less than 80 centimeter in thickness. I'm not talking of size, I'm talking of thickness, because these are normal bodies, normal elements, and their curing is also normal. Means normal procedure, as I say, number one you can use curing compound, number two you can use Hessian, saturated Hessian, number three you use combination of saturated Hessian. Actually, the combination of saturated Hessian and polythene sheet is very reliable. And other one is flooded with water, and flooded with water doesn't work that one. But I think this is better if you use combination of these two membranes for this Hessian, saturated Hessian placed on or overlaid by polythene sheet. Otherwise, columns, vertical surfaces can be easily handled by spraying a curing compound on water membrane, water, and keep it there. And top you can say use by water curing. So this is normal type of curing, or you can say fog spray, as they said, fog spray. That's also normal type of curing. Whatever we do on these members, that's another member, which is different one. We call that thick member, and that is whose dimension is at least 80 centimeter and above, and quantity of concrete of that member is 8 cubic meters. You got my point? That we call thick member. 80 centimeter, 800 dimension minimum, and 8 cubic meter concrete. This is fixed criteria, practical criteria. We define thick members as such. If we have thick members as such, then there are different considerations. Because member is thick and this quantity is thick, and this means heat generation capacity is also accordingly. So we have to take precautionary measurement for that. In this small member, heat is more. Where the slab is there, thickness is more. So in that area, whole heat is spread. Say 500 cubic meter concrete is there. But if it's the area of that divided by multiplied 0.4, you will get average release of from small area, from big area, small heat generation. You got my point? Area is big one, so heat generation is also small, because that heat is spread all over there and it's being released from every area. But here quantity is 8 cubic meter. 8 cubic meter means you are going to use at least 45 8 cubic meter, so about 50 bags you will use of and if one say one, I'm just talking OPC, just if you say OPC use 50 bags for this 8 cubic meter, this means one bag shall release I can say 40 bags, 50 bags, I'm sorry, 50 bags into say 45, so 2200 so many kilogram, more than 2000 kilogram carbon dioxide. This single element 8 cubic meter minimum would release this kilogram of carbon dioxide, and this shall be very fast, means how heat it should be. You can imagine if you use OPC for that, and heat release is enormous. Surface area is not enough to digest this heat, so there are possibility that this will impact on surface and from inside, and will find crack formation fast, or you can say very rapid your setting of concrete, and so there can be many kind of complications in such type of member. So it is called, we have to use different type of cementing material, and that's called cement plus supplementary cementing material we use. We can say we use OPC plus VFA or FGBS, or we use OPC plus microsilica, or we use OPC plus plus microsilica plus GGBS, like whatever combination, so that the heat generation is low, and we avoid release of carbon dioxide. So in this way, it's called thick member. This is one part, and also curing is in this. Of course, curing can be normal because this is not very big, massive member, and you can say you can use curing compound on that column or wall, or you can do whatever you want. On normal curing, we discussed before, but because it is low shrinkage cement, it shall take more time. Now come to another one, and one more thing. Sorry, temperature of this is also very important during curing. I just followed that. Temperature in ordinary concrete, as I said, that is restricted to 32 degrees Celsius in normal way. Concrete temperature, I'm telling, or as well as ambient temperature, you should not accept more than that, because 32 is the maximum limit, or you can say sometimes fluctuation is there. So maximum, some locations 35 is. Otherwise 32 is normal temperature in this type of concrete. And when I say thick member, it's 24 degrees, not even 35 degrees. That's another restriction. Now we come on to another concrete, that's called where size is more than 80 centimeter, as we said before, everywhere on this member, everywhere. This means even if it is, you can say, as you can say, so in this member, size is 80 centimeter, all dimensions, and quantity is about, you can say about 8 cubic meter. As we said 8 cubic meter before, it's about, it can be any, whatever quantity it can be, size is extensive. So it's called massive block. Means not mass block, massive block, which means it's a structural element having a power to damp vibrations. That means it's certainly going to be used for vibrating equipments, operating vibrating equipments like compressors, like pumps. Of course, it is supposed to stationary one, but machine foundation generally employs such. It can be generally massive block comes in that category. There are other machines also which are framed on. So framed one too gets one massive block, and upon that we frame it. Other structure on that in massive block where structure stays at heights. Compressor stays at heights. So on that massive block you have to again make thick elements, columns. Those columns are not ordinary columns, those columns are thick columns. If say I take, say for example, I provide one foundation, say 25 meters length, okay, 25 meters length, 15 meters width, or whatever width, 10 meters, and then depth is 2 meters, say, or 1.8 meters, say. This is massive block, and this is carrying, say, 10 columns or 9 columns, or whatever number of columns, depending on. And then columns go up to a height of 10 meters. All these are thick columns, say 2 meters by 2 meters, or 1 meter by 1 meter, or 1 meter by 2 meter, like that. And these continuously go up to that height. And there's another frame on that. That is beam frame, which is beam frame is frame. It's beam frame, but that is not thick. But depth is that much in some portion of that also. There's a thick part in that slab. And on that, rest, you are supported by bearings, handles to support something else. So that was the intention behind what I'm to say, what I said. This thick, massive block, come thick block. Massive come thick means base or foundation is massive block, and plus columns are thick elements, and maybe some portion of that slab on which this machine is going to rest, some portion of that is also thick element. So it's a combination like that, means it's a frame as well as massive block. So in that case, there's a very different arrangement for concreting, and that you have to apply same principle that you can't do more than 20, in this temperature limit is 24 degrees, same temperature, and maybe less is better. So this means you have to apply same chemicals in this concrete applied here, like so we have to understand all these points. So ordinary member, thick member, massive member. Now issue arises on massive member because we are talking of curing, and massive member means quantity maybe 500 cubic meter. If 500 cubic meter quantity is there, this means again you say you are using 8 bags per cubic meter. So 500 cubic meter, this how much? This way we have to understand now what we have to cure. You think now, and we think together. It's 500 cubic meter means 4,000 bags. 4,000 bags you have to use in this concrete of massive block, and 45 kilogram one bag releases. So 4,000 bags, 4,000 into 50 kilogram. This means 4,000 means 20,000, and then 20,000 and 2 lakh kilogram. 2 lakh kilogram heat you are releasing, carbon dioxide you are releasing 20,000 kilogram. 200,000, 200 tons. That much concrete cannot accept. So you have to replace their OPC by GGBs. So the 80% reduction in heat goes in. Now this 400 kilogram, that is carbon dioxide, if it brings down to 20%, this is 80,000, right? I bring down to that percent when I replace 70%, something like that. I mean just in actual figures you can calculate. In this 70% reduction I can do by reducing quantity of OPC or whatever is using, and putting GGBs in. That's first point of structural engineering. And still there, heat generation. Of course it is low heat now, so heat would be there. But I want that to be low, further low. What's method? And method comes from that. So point comes in how to cure that friction. That's point here we have to consider. Because we are using low shrinkage material, and we cannot use rapid curing method. Yes, we can use curing compound, but not immediately, because that will not work. There is a depth of concrete, there is a heat generation inside. You understand that? Heat is within this volume of concrete, and that is generating inside. That can impact all here, and it pushes heat up because outside temperature may be lesser than that one. Inside temperature is just 70 degrees or 80 degrees probably, I cannot say. And this huge mass of concrete, so much heat is coming out, and surface cannot take that. Surface cannot take that. What we should think of that in a scientific term, not in a just layman term, in a scientific term, we think a separate method, different method, means this wealth of heat I don't want to waste. You understand that? Now it's wealth for me. Yes, it is wealth. This heat of thousands of kilograms of this carbon dioxide I want to use for my curing. I am not having any instrument for that. No. I don't want any logic with anyone. It's not my concrete. It's someone else's concrete. So my point is, what you should do. This enormous quantity of heat, I want to use for curing. I don't want to lose it. No losing place. I don't want to take any risk. And I have to install temperature measurements also in this rising falling, so that I know what is inside and what is on surface. I don't want a thermal impact on concrete. Thermal impact of concrete is not allowed. It's not allowed by me. I don't allow thermal impact of my concrete. So what engineering says, what technology says, I want thermal energy to be used for hardening of this concrete. Very simple. It's very simple. There is no concrete, no rocket science, no very integral or calculus. Limits are there. Internal temperature is this, external temperature is this. Heat value we can find out. But there always the thermal principle, thermodynamics principle. High temperature moves towards low temperature. So outside temperature is lower than inside temperature, and much lower, and that's much higher. So to maintain, you can say thermal still like that. Okay. This means we have to use common sense rather than engineering sense, right? There's no engineering answer. Common sense is more than engineering sometimes, Civil engineering is 50% based on common sense, and 25% based on theory, and 25% based on your practical experience. So use common sense, because civil is common sense. I want to close this heat within my this block. I don't want to allow this to go away. I don't want to allow this heat to go away, but this bank of heat I want to keep in, and let concrete absorb this. You will say, what do you mean concrete can absorb it? Yes. Concrete has released this, it has released this, but has to drink its own fruit. That is where sense is. That's where we think of. That's where we have to understand, we talk of, and we have to do it. We have to do it. No way why, how. It's to be done. That's why do it. That's to be done. So what we do? As an intelligent engineer, I want to lock it, close it, exposed surface of concrete, one part, one plan. Others are already closed. All sides are closed, four sides. Top is not closed. So let us close it. How? Let us say I put a plastic sheet on that and I bring something, say polystyrene on that, or if I don't find polystyrene, then okay, let us bring a truck of dune sand if it's available and put on this dune sand. Spread just a 4 centimeter, I will say 4 inches thick on that, and cover it by any means. You can cover anyway. You can bring some polystyrene, you will cover on sand on that. Means you just make it airtight. Air should not go from out to in, and heat should not come out from the air. If you make it that, you make it tight. Yes, there are dowels of columns that you also tie up. Means you put that also tie. Or if you can't tie them, put some water in that. That's it, nothing else. Outside are closed. Tighten it on 4 sides through where heat can be released are now tightened, are closed, sealed. Heat is not going on. Only chance is that it cheats me. It cheats me inside. Okay, you don't allow me to go from here up. I can go from sides. After all, it's heat. Fire ultimately, it's son of fire, wasn't thought of fire. It won't limit. It has no limits. So okay, I go through this shutter, a shutter of sides. Okay, I know what you want. So I start shooting you. I'll use shooting you with the water spray. I know temperature inside is 70 or more. Temperature inside is in core of this massive block is more than 70 degrees Celsius, or could be 80 degrees Celsius. And outside temperature is this 40 degrees Celsius or something like that. So there is a gap, that's a big gap. Thermal gradient is big one. So certainly that 70 degrees should push towards outside. It's 70 inside. So maybe inside just close to this sides. Say it is 70 again. Outside is 40 degrees. So what we do is spray from outside all around and capture this heat, and we keep all sides cool. Whatever way, you put more water on top, you spray water all around, or do whatever you can do. No heat transmission out. No allowance of heat transfer from inside to outside. We capture it. And we also provide certain thermal couples, the temperatures there, to monitor every hour what is change in temperature inside and what is temperature outside. It will fluctuate because their temperature are different, night temperature are different, but there inside light temperature is not a problem. It's not a problem at all. So what does it mean? It says 7 days, okay, so 10 days, whatever initial curing is required, we monitor temperatures. That's done. We record the temperature, what's thermal gradient starting after 1 hour, 2 hours, 4 hours, like that. Whatever is procedure specified, and we do that. And we see, if you see there is a big thermal gradient, how to keep that. But certainly heat is inside. So what shall happen? This water spray which you are doing, area outside say 30 degrees, at night time it will be 25 degrees, 20 degrees, and inside and outside. It will not transfer to outside because we are keeping it cool. That heat outside, cool outside, may go in and condense that. The all-time high temperature cannot move it. Means that high temperature, so condensing by taking out water from cement. So that high temperature condenses it, and condensing is dries is cold. But we can maintain, and when we see that curing is done and is responding, and then we go to some other problems, but then we see what it's So that was after 4 days, 5 days, 7 days, when you fully go in. So when you take out after 7 days, you shall certainly take out everything, because initial curing was important. Means we have protected that heat. Now it shall not go somewhere else because concrete is already hardened, and we can take out sides and immediately we can pour water on that and spray compound on vertical sides. It's suitable. It's because we are not to walk on that. That membrane which you form there outside shall not break, and top surface you can go provide curing compound, but still there's a problem in hardening surface. So better you cure accordingly, and once 7 days over, then that heat is gone, and it's now normal, because on the top surface you have to keep wet. Vertical surface is already provided with curing compound, and use this way for a number of days. So that is about massive block curing. Then you have to go up and start your thick elements, and as I said, all columns are thick, so you have to do accordingly. And then thick elements you do formwork with a couple of time, you have to fabricate formwork, and you have to insert plates inside many tanks, and all this whatever is done in this protection of that concrete, and it's an industrial project. So you have to cast those columns, and of course same 24 degrees Celsius temperature, and GGBS concrete, and same way you can cure ordinary way by putting only temperature controls are very important, and frame on top is different. So this was all about is how to understand curing management, curing organization. we consider curing material self-organization. This is one possible technology. We have space, time, and we have to. Now, I think curing, which is a different world here, it's very important for field engineers, for site engineers, for project managers, and also for design parts. My dear friends, it's not worry part, but it's preventive part. There's nothing to worry from hearing. There's worry only that. So let's go. Curing world is very very different world as far as I understand. It's completely different world. It's very very responsible world because ultimately this is curing only that's going to keep concrete alive. If there is no curing with concrete, it's nothing but soil, it's nothing but sand. So concrete means curing. Hardened concrete is result of curing, and if hardened concrete is result of no without curing, whether it's thermal curing or it's water curing, then that concrete can't be used. You cannot say that concrete is. It may solidify, but it won't have stress and stimulus. And therefore, so now we think of some other methods. This was curing, and you can take something. We can take contractual issues. So we move now on to different world where we find that without which you can't be able to go. So, if we say we want good concrete, means we want good working, we want good design, we want good soil, and we want good pouring, and then good controls, and then you can say it is quality. So quality is a very big element here. Quality element involves all divisions. There is a time limit. Time is going to change. That's a fact. So quality, if you can achieve, I think that's a break in life. If you can achieve quality according to requirement, you are an international engineer. You are a professional engineer. Otherwise, you are not an engineer. Because you can't give quality, then what for you are here? My simple question is engineer supposed to give quantity only? If you say this is quantity, I understand this is quality also. Quantity means quality is there. If no quality is not there, then I don't accept your material. I don't accept it both. Because I am paying you for both, for quality and for quantity. It's not that there's a quantity without quality. There's no agreement. So we have to understand very differently meaning of quality. Because this is very important point that we people have to understand. And we talk of contract in this connection because contract is very important item here. Without contract we cannot do anything. Contract is contract, and we have moved to contract. We find so much information here and there, and that's important is contract, because contract is everything. If your contract is defective, you are defective. Your mind is defective. What is contract otherwise? You think it's a document? No. You think it's a statement devised by some lawyer? No. What is a contract? What is a contract? What is a contract? Whether it's EPC or it's construction contract, it's red book or it's silver book. What do you mean by that? Is it just signing documents? No. Contract is an engineering document. Mind it. It's not legal document. It's legally based engineering document, without which you are not going to work. If I am working myself, that's fine. No need of contract. Even then, I shall have to enter into contract with vendors. If I say no, I'll do job myself, but I have to purchase materials. I cannot manufacture materials myself. I have to buy every material. I have to hire people. They also have to be contracted. Everywhere I have to buy equipment. I have to buy machines. That's also contract. So I cannot avoid contract even if the job myself as an engineer. Which means every contract has its own merits and precautionary measures that requires to be taken so that each party move to its obligations. We simply cannot speak contract and go. You cannot go, and I also cannot go when we enter into a contract officially. Because contract is not an obligation alone, it's a commitment. It's not simply you pay me as I work for you, it's a bind, it's a responsibility. And this responsibility does not stay at one party alone. It is automatically transmitted to legal successors. It's automatically transmitted according to contract law. Even if I am employer, I am responsible. After my hereditary are responsible. You are a contractor, you are responsible. After you are their heredity are responsible. So it's generation contract. Do you understand that? It's generation binding. You can't skip at that. You can't skip at that at all. Because you are registered somewhere and I am also registered somewhere. I am registered as a company, you are registered as a company. There's a record there. If you don't tell me automatically registration number is there, I can take out papers from there and go to court and say this has cheated, this lied, declare who is legal. I'm dealing with that. It happens. So contract cannot be taken just entertainment statement. This is a binding work. It's engineering binding work. And there is no need of defining separately quality in that. Automatically it's understood. All contract documents speak together. All contract documents, your contract, your acceptance letter, your bid documents, you can say what your particular conditions, your general conditions, your project specifications, your general specifications, international and national codes, your drawings and all, and complete whatsoever else, even your schedule, time schedule, agreed later on even, and all those whatever are linked to this, complete package is called contract. It starts all documents, thousands and thousands of documents, not simply drawing. All drawings, I call them all drawings. I am having drawings of my contract. You will say, okay, let's see, draw a contract. Draw a contract means what? Make a contract conditional form. Draw this and draw that means what? That's also a form use. So it's not simply your technical drawings. All contract is a drawing in itself. It's very complicated arrangement if there is dispute, and it's easy arrangement if you both parties understand each other. They have mutual understanding into a spirit. We call letter in spirit. Just we say we agree both together in letters and spirit. Neither separate letters nor separate spirit go together. Because life is body and body is body plus soul. If body loses its soul, it can't move, it can't work. Same is contract. Letters are there, spirit is also there, and that spirit is commitment, that is with oath, that is with solemnity, and that is that I have to do this for you. And if you break that spirit, contract can never move. If you break that trust, you can never move. There are hundreds of questions which are understood, which are solved. Everything cannot be written. There is no need, but professionally what's required, that's written. It has to be signed somewhere. That has to be written. But what's my mind is, my heart is, I have to do. What I sworn in, I have to do. I sign undertaking there, affidavit there. I do that. So something is worth writing, something is unworth writing, because you cannot write anything. Just like I say good morning, do I write in contract? I will say to you good morning, no. Or you say, okay, how do you do good morning? You don't write in contract, how do you do good morning? So that is something which is understandable. Means you have to respect each other. You have to make mutual respect. That's not written. You understand, but that is done. Life is that. So trust, degree of trust is this way, and degree of mistrust is this way. That is contract. Trust building is like say confidence building. So both parties must have tolerance power, no domination over each other. And where domination exists means there is defect in contract. Administration is one part. I am not talking against administration. I am talking of domination or dictatorship. That is not acceptable in contract. Because you are not doing any obligation on me. You are paying me and I am exchanging you this payment with what? That's how. You are not doing anything special to me. I am not doing special to you. Both are working for consideration. I am getting this consideration and you are getting work consideration. This is mutual reciprocal deal, practical deal. There should be no deception, deceiving or anti-legal measures. There should be no dispute. Unfortunately, there are disputes, unfortunately. Such disputes which are created disputes, which are disputes with malified intention, not with good intention. Those disputes are done because your mind is corrupt. There's something else in your mind and you are signing something else. That's why it happens. And then we go into the hands of others. That's unfortunate. My money I am giving you, you give your act, that's it. My money I am giving you. Your job you are giving me. This is contract. I am just inviting third party. There's a dispute between two and you solve it. That third party is not a party on contract. We go to appoint that party. Please help us. We have a dispute. And we pay for that. While there is no such need in contract. Yes, there is condition. I understand. There is condition in every country that dispute resolution mechanism is there. But question is why dispute? When there is no room for dispute in contracts. These are not disputes of family. These are not disputes of husband and wife. These are no disputes. This is strict work. Before signing, you read contract. Before signing, I read contract. Yes, we can miss something. We understand that. I can't say no. Everything is not mastered. I can also miss. You can also miss. For that, we can solve this problem. If you have a problem that I am not paying you in time, you can tell me something is wrong there. And I can also tell something is wrong there. Because my goal is project. I want to see that project start running. It should lose its project. It should start running for my benefit, for my stakeholders' benefit, for your benefit as well. Because you have to come out discharged from that project. So it's benefit for everybody. But this benefit goes to those people who are not at all involved in this project. That's a major point of concern. Though I have expertise on that, I understand how to resolve disputes, how to solve disputes, but that especially is considered that sometimes because we do not have that degree of access. We want to play with each other, and that's not really way of dealing project. It's unnecessary. We show our weakness to others, and once you will start disputing either myself or yourself, either we are disputing as first party or second party, then we can't continue in market after that. Means in no way we can continue in that market because we have some frictions, professional frictions, undue frictions. So nobody shall like to share your business in that. This means until it's impossible, until it is possible, we should solve matter on site. Just like we say, you solve your family matters in your family. This is your family issue. Why you are bringing on road? Do we say or not? There we take our respect at higher level. Oh, this is family matter. Don't disclose it. Don't take it to court or don't take it to somewhere else. There our respect is at stake. What about here? Is that contractor whom I hire, he has no respect, you think? Or I have no respect? We both have respect in society. So my criteria is contract should be structured in such a way that it helps both. It doesn't stay in way, oh no, I am higher, you are lower. This is my right and you are not giving my right. I say this is my right and you are not giving my right. In this clash, project collapses. in disguise. And those people who may be your staff, high profile, they may be playing with you indirectly, you do not know. They may be having your secret documents. The other party has its own secret, and these, how can you guarantee these people won't meet each other? These people together won't help each other to cross us. Can't you say that? Everything is possible in this world. I cannot trust people because I have seen people do that. People are sometimes, though they are loyal to you, they'll show you loyalty, but they will be disloyal to you as well. It's very important point. This is not part of FIDIC. This is part of humanity. This is part of real living. That's why I am sharing with you. It's better to avoid disputes because contract itself is a future for you. Do not sign contract blindly. That's also important. Read it, analyze it, understand it. Is it practical or it's not practical? If you think it's not practical, discuss with that party. You have provided this. This is not the means both parties can agree on anything because both parties do not know what's the actual intent of contract. There are some people who devise this. For example, FIDIC has devised something, but FIDIC also doesn't have thorough knowledge. They can also make mistakes. After all, that's an institution, and there are many hands there, and those are all not experienced in a particular field, but they can also make mistakes. You have to understand that. So we do not know what is total content. I do not know. So we either depend on others' minds that they have devised for us. Oh, he has devised, he is expert on this, he cannot make a mistake. No, that's not real. That's not real. It's better to be late than never. We say that. So what I'm talking is saying, we have to be late than never. And if we are late than never, we can get benefit of that in life. And that's where life lies in. I don't want to waste time on dispute mechanism, dispute ecology. There's an engineer on every project. He's independent one, that party. You believe him. When you believe in it for work, he inspects your work on behalf of both. He approves of. There you believe. You trust him. Okay, fine. You have your all stuff. You believe them. When you believe in all work, why only in some percentages you don't believe? You accept that decision. Maybe you lose some or you gain some. For that why you waste your time? You shall pay huge amounts to those people who have nothing to do with the or those law professionals or professionals like me. You have nothing to do with the project. But only difference is I understand technical, what's right, what's wrong. But I will also not misadvise you. I will not give you bad advice because I am an engineer. I can't say what a lawyer thinks. I can't say what a judge thinks. I think in technical way. Maybe I don't understand and advise you both something which is against me, against my profession, and you pay. Okay, no problem. After all, I am from same field. An engineer understands better than somebody else. Only judge is engineer on your project or some other engineer. Because the mind of engineer is not like mind of lawyer or mind of judge. We have clear mind, clear conception, and we do not stop at comma and full stop. Remember, we are not that type of people. These people stop. Lawyer, there is no comma, there is no question mark. Just argue on that. Why this comma was missed? Oh, this was missed. No. Give me evidence why this was missed. Complete nonsense. You are arguing on comma and full stop. You are arguing on why you did not issue this and why. Oh, we did not sue him. That's it. Why should I explain? This is site. This is work. It's practical work. It's not your court. Here everybody is down. Here everybody is up. Time is long. No time. I have to issue. We have to hand over project. Understand this. You are not caring for your judgments for 20 years. What shall you decide for me? You do not know anything about that person. What shall you decide for me? Therefore, better avoid disputes. My suggestion is that, okay, I won't get job of arbiter, no problem. That's not end of my life. But you are losing. your project is delayed. In some, though legality says, contract says you can't stop project, but practical is different. When contract is in tension, that person will not think for that project, because ultimately that person is going to lose. Already that person is going to lose. Okay, I'll pay limited risk. I'll pay damages, no problem. I shift this resource to other place. Bring some other people and do it. This kind of clashes starts. Means a kind of rigid approach from one side, and then super rigid approach from other side. Okay, don't do. I'll bring. So you are harming your project. You are not harming someone else. You worked 90% good on that project, or 95% good on that project, and for 5% you are going to fight together. This is childish behavior. This is childish behavior. I don't say arbitration is good or bad, but when there is no way out, first stop is engineer, who is independent party, accept that and solve problem. Perish. That is not your enemy, but that is not judge also. That is a brother for both, because he has no interest. He is not going to even charge fees. Understand? You will pay fees to DAB, you will pay fees to arbitrator. Here he will not charge anything, because he is committed to project. No separate fees for him. Either it's employed by employer or fee based. So this is not part of arbitration there. There his judgment is binding on both. So better accept there. Don't spend further, not even on DAB or DAB, and forget arbitration if you want to comfortably do your project. Otherwise, you are master of your work. You can do whatever you want to do, stuff here. My advice is, project value is higher when it is operated, or when it's brought into commissioning and use. That is more important than leave aside this arbitration, because their beneficiaries are judges and lawyers, and those who have nothing to do with their project. So I don't want to get them benefit. Why should they be benefited? And ultimately it increases cost of project, and that cost of project increase means consumer has to pay more, and you have to spend more money on that. Best is accept engineer's advice. Your engineer, I'm talking engineer on project which is mentioned in the contract, because that person is certainly an engineer, and that person understands better than anybody else. Why should they cheat you when he's not getting any benefit? Why should he? You may think, oh, he may take commission. What for? Did he take commissions for your project? He approved hundreds and thousands of papers. Did he take for that? No, because that was paid. He's professional. His job is that. So it's better always on engineering contracts, on such EPC or on such construction projects, forget arbitration and forget court. Let them stay them where they are, and compromise is better, I think. Though I get also benefit, I do consultancy for arbitration, but that is different means. But I say don't do it. I will not get anything. My colleagues will not get anything. Why? Am I living from your money? No, I'm not living for your money. My life is there. I am in just somewhere, maybe I get money there. I just bring, until there is, complete remote chance you can't do it. And that's not possible. That's not possible. I'm saying that's not at all possible. So that's my suggestion, only solid, concrete suggestion to all parties. Do not fight. Fight is there. It is a must for work only. Always there is fight. Everybody fights for his rights. If you are not giving quality, I shall fight. If you are not doing progress, I will fight. What's wrong with that? Because you are interested somewhere else. I know that. I am interested for this project because I am in charge of this project. I want this project moved. You want your project moved. That's because you are contractor here and you are contractor here. So I would force you to add resources here and do it fast and do give quality, and that's only then no more the thing. And I will force employer also pay you in time. And if employer doesn't pay, okay, stop work, simple. One time you remind, second time if that person doesn't do it, you will stop for, give notice and say, pay me money, I'll do it. You will get extension for that, don't worry. You will get extension for that. Nobody can stop you from that. But that should be clearly done. So you will say he's talking indefinitely. No, I'm not talking indefinitely. This is professional talk. This is not commercial talk. This is not legal talk. I'm not working for lawyers. I'm not working for judges. I am working for public. Whether I'm in government sector or I'm private sector freelancer, I'm working public. My service benefit should go to people of this country and not to someone else. That's what is required. And if you spend, say, crores of rupees on arbitration, this crore should go to consumer rather. Why should arbitration benefit? Why should lawyers to benefit? No, they should not take benefit. And that's what I say. And I thank you very much. I said, when I close it now, you'll say this person is cracked. You may say, yes, I am cracked. Because I am stopping way of those robbers, they want to make lakhs of rupees for one sitting, and these people spend money for nothing, and those who work throughout that project, they get very little salaries, and these people do nothing in that project and they get back money. So that's one. Of course, there's a consideration. Why should somebody get undue benefit? Lakhs of rupees these retired judges and senior lawyers, they charge per day. Why should they charge? What is their contribution? My point is that, yes, why should they charge? Question is that or no? Okay, either you charge normal for the 5,000, give me for one sitting, 10,000, that's acceptable. Which other, what an engineer salary is 50,000, maximum 100,000. If it's say a good engineer is getting 100,000 per month, 3,000 per day, 4,000 per day. Are you bigger than an engineer? My question is that. Pass engineering and see. Go to engineer college and see, can you pass engineering? Law can be passed. There's no mathematics in law. Don't forget, half law engineers know. If they are real engineers in contract, they know half of civil law. You don't know 1% of engineering. That's the only difference. You say, what nonsense is talking completely non-professional law. Yes, this is real professional talk. I am talking in interest of projects. I am talking in interest of national development or industrial development. I am not talking of wastage of money and public money. Until I say, until and unless there is neck out, don't dispute. Small amount, digest. After all, you are doing project. You have to do many projects in future. Maybe somebody make mistake. Maybe engineer ignores something. You can later on tell him, see, you got me losses, indirectly losses, and which was not right. Engineer will adjust somewhere. Don't worry about that. Revisions can be made. That's not hard and fast. No, sometimes errors happen. It is human being after all. So we that's digestible. Orders can be revised, even valuations can be revised, variations can be revised. Okay, we made mistake, what to do? Something happened somewhere, we review that. Quantities can be wrong, we revise that. So there are ways, maturity is that. Fighting dispute is not mature until, yes, there are other disputes, arbitration disputes, litigation, or in insurance, or somewhere else. That is, I'm not talking about, I'm talking of construction contracts. Because you have to give quality, spend money in quality is better. You give value to honor, this better, employer. You spend that money there, you will get benefit. People will say, oh, good construction, very good contractor, very good builder. That's required rather than wasting money to these people who have nothing to do with you. That's why I had to say, please don't mind this. My nature is that. You have to speak frankly if you really want to do something in this world. With this, I say, I close this dirty ending talk. It should be actually happy ending, but I am making sad ending, and you know what, dirty ending. Okay, no problem. Thank you very much, gentlemen.